I'm the guy that spends the time at the drill rig looking at the samples. In the horizontal wells, I'm involved in the steering as well as sample identification, formation identification. When we drill vertical wells in Pennsylvania, my job is usually just involving the geology, sample description. In New York, where wells are typically smaller, easier to drill, often I'm the only person there running the show. So that's the background I come from. Graduate geologist. I've been doing well supervision, water wells, gravel pits, you name it, for more than 30 years. Almost a lifelong resident of this area. I grew up in Trumansburg. Anyway, this evening we're going to talk about drilling as it's done in this area. We're going to talk about fracking. And then I want to, after we let Tom Shepstone from Pennsylvania do a little talking about their economics and roads and so on there, I want to come back and finish up discussing some of the problems and perceived problems. Roads, radioactivity, water disposal, that kind of thing. I think the best way to approach this is let me ramble on for half an hour or 45 minutes, and then if I don't adequately explain something, feel free to ask some questions. To get started, I'd like to point out that drilling and fracturing, hydraulic fracturing, we're going to use that term interchangeably here, are two distinctly different events. Drilling is putting a hole in the ground. Fracturing requires the hole in the ground, but you can complete a gas well or an oil well without fracturing it if it encounters what you want without fracturing. The fracturing by design is to stimulate production, get the rate up to where it's economic. That's what a fracturing job is designed to do. You can fracture rock, cracked rock, that's really what we're talking about. A number of ways. If you like a little more excitement in your life, you can do it with explosives. The old days, we shot a well with explosives last fall, an oil well, down in western New York. The penetration of the cracks propagated in a shot situation are probably out of the order of 10 feet. And we know that partly from production characteristics and also from running what we call caliper logs in the wells after we've shot them, after we clean them out. The reason the industry has gone to hydraulic fracturing, and hydraulic fracturing is simply the pumping of a fluid. And you can pump any fluid, any kind of a liquid. Hydraulic fracturing works basically the same as the hydraulic system in that tractor back there. You build pressure on the surface, pump it through a pipe down a well to where you want to break something, and if you build enough pressure, something will fail, something will break. Hopefully it's the rock that you intend it to be, and that crack propagates back into the formation. That's the plan, that's the desire. And we also, in a gas well fracturing or oil well fracturing job, we want to place some sand. I got a container here of frac sand. If you look at this closely, and you were at Bill Capel's speech a couple of weeks ago, you'll notice this sand is coarser. And there's different gradations depending on what you're trying to do. In a conventional vertical well, the goal used to be, and still is for the most part, we want to make a crack 5 sand grains wide. And the reason for that is that's to be the conduit back to the well bore as well as the production face. When you drill a hole in the ground, 6, 8, 10 inches in diameter, whatever it is, the circumference of that hole times the height of the formation is the productive face. If you propagate cracks, one or more, back away from that well bore, you then expand the productive face into that well hundreds, 1,000 times. And some of those cracks go in a nice straight line. Some of them intersect pre-existing cracks, tend to follow them. Some of them propagate new cracks. And the goal is to drain the rock formation. And we're talking about a hard rock. I brought along a little of the Marcellus here. Bill Capel had some core pieces. This is what the Marcellus looks like from 10,000 feet, 5,000 down, 5,000 over, from a well in northern Pennsylvania. It's typical black shale. This is what I get to see after I wash it out of the drill cuttings. So it's nice to say it's black shale. We can describe the carbonate content, see how hard it is, see how it breaks, that sort of thing. But most of the analysis of the shales comes from the actual fracturing and the results, the hydraulic results that it produces. Now, let's take a look at our area. Anybody that's been to any of these talks in the past has probably seen some version of this map. This is right out of the New York State Draft Environmental Impact Statement. The original version is color. I'm too cheap. I made a black and white version. Pennsylvania, New York line. This is Lake Erie. Syracuse is up here. We're right here. And I've added a few things that aren't on the New York DEIS version, and we'll come back to that in a moment. When in this county we have probably 100 gas wells already. They're situated up here in the north end, in the vicinity, town of Fayette area, and you drive any of the main roads, you can look out across the fields and you'll see usually a tank and some assorted plumbing beside it. To drill a well in New York, the first thing we need to do is drill the bedrock. In this particular area, and a lot of you guys farm, you know, you don't have to go too far to bedrock, 10, 15, 20 feet or even less. Whatever depth it takes, we want to get to bedrock. Same as if we drill a water well in your yard. And the purpose of that casing, that first casing we're going to put in the ground, is to simply hold the well open, to keep the dirt, the gravel, till, whatever you got, out of the well bore. And we want to seat that in solid rock, just exactly the same as your water well. Then your water well contractor drills inside to whatever depth he has to go. Hopefully you find some water and you're in the water business. When we're drilling a gas well, we want to get out of the water business. We're looking for gas, obviously, or oil. We start out the same way. We set conductor to bedrock. Then the state of New York requires a minimum of 450 feet of surface casing, of water string casing. It either has to be to 450 feet or 75 feet below the deepest freshwater zone, whichever is deeper. And there are some situations where it's actually less than that, but they're dictated by the local geology. The first casing can be driven into the ground. If you drill a hole bigger than the casing and you set the casing in, it has to be grouted. It has to be cemented around the outside. However, if you drive it, what we call drilling and driving, the old-fashioned cable tool rigs drove them into the ground. We now have modern rigs that are capable of drilling inside and turning the casing at the same time. We put some carbide buttons on the bottom of the casing and drill as deep as we like. Conductor's pretty easy to set in most of the town of Covert because the depth of rock isn't very deep. Go drill in downtown Ithaca, you may put in more than 500 feet of conductor to get the bedrock. Same is true of Watkins Glen and in the lake valleys. Once you get the rock, then we've got to set our water string 75 feet below the deepest fresh water. State rules, this has got to be cemented in. And because we've drilled inside the larger diameter hole, we now have a space in between this casing that we've got to run and the hole. This is called the annulus. We've got to fill this with cement. We do that by pumping cement down the inside and circulating it back up around the bottom. up around the bottom, all the way back to the surface. If it does not come back to the surface, we're going to be obligated to pour some in from the top. We circulate usually 50% excess of the calculated volume to help ensuring that it makes it back to the surface. If it doesn't come back to the surface, you're also obligated in most situations to run a bond log, which is a run on a wireline truck. It's another $5,000–6,000 of expense that you don't want. Cement's a lot cheaper. We want to cement this guy in. That's our goal. Then, typical Medina well, you're off to the races drilling. You can drill as deep as you like. Most of the wells in the north end of this county, a couple thousand feet deep, more or less. You have two options. You can stop. We need then to run one more string of casing, because at this point you've got a long well bore full of open hole rock. We want to contain the gas, get it to the surface where we can sell it. We run a production casing. Typically this stuff right here, 4.5 inches in diameter. It either goes through the zone of interest, and then if this is our zone of interest, we're drilling down here. We run the casing through, same deal. We got to cement him again. We pump cement down the inside, back up around the outside. Some areas of the state, we don't want the cement to come to the surface, but in most areas we do. And so we want to completely fill this void, this annular space outside the casing. The demonstration right here, these annular spaces are not big enough. State law requires a minimum of almost 2 inches depending on the casing size, and there's actually a chart for that. Once you've cemented this guy in, we've then got to shoot holes in him. We literally go in on a wire line with shaped charges, and we shoot a hole through the casing. It makes a hole exactly the size of that pencil, believe it or not, and I've actually had to fish them out of wells to look at them. They're just like a bullet hole, right through the casing. Then, if the formation will give you whatever fluid, whatever gas it's got, that's good enough. It'll come through the perforations, flow to the surface, you're in business. Most rocks in New York will not. That's where the frac job comes in. In a vertical situation, you'll typically have 50 feet or less of formation exposed in the wellbore, holes through the casing. The frac job is then, we hook out at the top of the casing, appropriate valves and pumps, pump fluid down, out through the holes, into the formation. We literally exceed the breaking strength of the rock, either propagate new cracks or open up existing cracks. The reality is it's a combination of both. And when we get done, we want to fill that crack 5 sand grains wide with this stuff. And so typical vertical well frac job takes a couple hours in the morning, takes longer to set up and rig down, and they're gone. $30,000 and goodbye. And then at that point you're left with a hole full of fluid. You got to unload and produce whatever the frac job encountered. That worked pretty good for a long time, continues to work. A little bit of history here. About 10 years ago, natural gas was starting to get short supply. Price was going up. The minute it's no different than growing corn or milk or anything else, what happens when the price goes up? People start thinking of ways to grow a little more, produce a little more. The industry continues to explore for new reserves because in the gas, in the petroleum business, you continually produce yourself out of a job. There's only so much finite reserves that you're going to produce. As you produce them, at some point, if you want to stay in business, you've got to go find some more. You've got to drill another well, or a series of wells. 10 years ago, in this yellow area right here, Chemung and parts of adjoining counties, the Trenton Black River Formation, depths typically 7,000 feet below the surface, was drilled and found to have natural gas in zones that were specifically defined by seismic modeling. seismic crews run up and down the roads, put out a bunch of sensitive geophones about some kind of shock waves generated by explosives or vibration, and the interpretation of that defines targets that we want to drill through. The initial Black River wells were actually vertical holes, and the industry said there's a better way to do this. We want to go through those, for the zones of interest, which are actually fault plains. We want to go through them horizontally. So the horizontal industry came to New York. Horizontal drilling isn't new. It's been around for 20 years, but its application on land in the northeastern U.S. is really new in the last decade. Anyway, when we start out to drill a horizontal well, we do it exactly the same as a vertical well. We start out with casings. We still have to comply in New York with the minimum 75 feet below the deepest fresh water. The fun part about drilling to the Trenton Black River is we have a couple of zones on the way down that give us a little trouble. And trouble is spelled salt. And immediately below the salt beds, we have a water-sensitive shale. And so if you can drill them dry, there's no problem. If you drill with compressed air, no problem. They drill, they stand up very nicely. You can drill as deep as you want to go, wherever. If you get them damp, you get them wet, the salt will dissolve, make an oversized cavern, stuff starts to collapse. If you're drilling in a water, any kind of a water-based fluid, or the hole's making any water, the water-sensitive shale underneath wants to fall in on you, grab you, collapse the hole, the fun starts. So typically, what we do to deal with that is we run another string of casing through these zones that give us trouble, the salt and the underlying shales. So, to drill a modern ultimate, starts out vertical, then goes horizontal. We start out with bigger casing because we need to run more of them. And each time you run a string of casing, you can see here, they step down. They've got to go smaller. I've even brought along a little bitty drill bit. He goes right in there just nicely. I can't pick up the big ones, so I can't show them to you. But typical horizontal well starts out with like a 20-inch diameter casing. If you have the right drilling equipment, you can literally screw it in the ground. The same way we drilled this conductor here. We're putting it in for the same purpose. Get the bedrock. Hold the soil, the till, the rock open in anticipation of going deeper. If we can't turn it in or can't drive it in, driving big diameter pipe's hard to do. It likes to buckle. It doesn't cooperate like little stuff does. One way or another, we got to get that big conductor to bedrock. If there's any void space, any annular space on the outside, we got to cement that. Then we still have to contend with fresh water. And if we do it in New York, we've still got our minimum 450-foot rule, or 75 feet below deepest fresh water. A number of companies elsewhere in the world will make this 10% of the anticipated total depth. And so if I'm drilling a 5,000 or 6,000 foot horizontal Black River well, I may make the water string 600 feet long. But I got to have a minimum of 450 under present New York rules. Once I run that in, I got to cement that same way. In this sketch right here, it's 13 3/8 inches in diameter, standard oil field size. Then I'm off drilling. I can drill as deep as I want to go inside there with a 12.5-inch bit, and we typically do that through what we call the burning shale, the water-sensitive shale. In the case in this area of southern New York, 4,500 feet, something like that. This stuff weighs 36 pounds to the foot. It takes a little bit of a derrick to pick it up and plunk it in there. And same deal, it's got to be cemented. So we circulate cement down the inside. Some of these cement jobs can exceed 1,000 sacks of cement, and you mix a sack with 6.5 gallons of water, 5.5 to 6.5, depending on the additive. So the cement jobs are a big deal. Any of you that have poured cement, and we're standing on the floor covered with it here, know that it'll set up in a couple of hours. Normal Portland has a gel time. In order to physically get this stuff in the hole, to pump it in at 100 or 200 gallons a minute, we have to calculate the time it's going to take for it to set. We sometimes add chemicals that either retard the set or advance it. Portland cement has another bad habit. There's an extended transition period from when it goes from a liquid to a solid. Now, in this situation, I'm talking about cement with no aggregate in it. I'm talking about what we call neat Portland cement, and we pump the stuff. So we have to deal with the chemistry of the cement. To get back to the transition business, if I've got a long column of cement here, and the cement here is represented by the Hatchard zones on each side of my casings. The cement column needs, number one, needs to circulate all the way back to the surface and needs to set. I've got to be able to pump it and get it to where I want it before it'll gel, before it sets. If the transition time is too long, anything that's out here in that hole that has some gas or some oil or some water into it, when it's in the transition phase, as it's going from a liquid to a solid, it doesn't exert any hydrostatic pressure. Hydrostatic pressure is the weight of a column of fluid, and fresh water is 0.43 psi, almost half a psi, for every foot in height. And so if I'm down here 5,000 feet, I've got better than 2,000 psi of pressure in this cement column outside the casing. Right at the point where that cement gels, it no longer exerts that pressure. That's the point at which cement can be channeled if we don't do something about it. And we do. We add a bunch of additives to shorten the transition period and try to ensure that that cement won't be a problem somewhere down the road. Once we've done that, we've got our salt section behind us. We can go on. We drill as far as we want to go vertical. We get to what's called the kickoff point. We then are going to turn to horizontal. You take, this guy looks pretty rigid. You get him 40 feet long and you suspend him on both ends here across this shop, he'll droop. And steel casing, steel drill pipe has got to be able to go around this curve, and you've got to do it within the elastic limits of the steel, because we're going to turn, we're going to eventually run production casing around here, but in the meantime we've got to be able to turn rotary drill pipe around here. When we're building angle, we start out to build this angle. Incidentally, the radius on this circle is 500 or more feet, the radius. So to get around the bend, it's about 700-800 feet around the bend, or more, depending on how you design the weld. Steel will track around there. When we're setting out to build the curve, we actually use a bent drill string, typically about 2 degrees bend. And we have a bit like this. He's larger than this. There's a couple of different kinds of bits we'll discuss here in a second, but we have a bit on the end. Behind that, we have a motor. The motor is actually a turbine. And we pump fluid down the center of the drill pipe that's connected all the way down to this motor, and we can either turn the drill pipe if we want to go straight. If we want to bend, we just hold the drill pipe oriented in the direction we want to go, and we spin the motor by pumping fluid. And we can build about 8 degrees of angle per 100 feet of digging. You can actually get up around 10 or 12. You're approaching the elastic limits, and sometimes things don't always behave quite the way you want them, so you want a little margin for error in all of this. At any rate, to build angle, we don't turn the drill straight. We simply pump down it. We orient the bend in the direction we want to go. We build the angle. Once we've got the angle built, then we've got to stay in the formation. Well, I worked on a formation here a couple of months ago that was only 10 feet thick. I'm going to tell you what, trying to make this guy go half a mile in a zone that's less than the height of this room is not quite as easy as it sounds. If the formation you're in is as flat as this floor, there's no problem. If he wanders around very much, it's a big problem. But anyway, let's in the Black River, we typically were looking at a target that was 40 or 50 feet high. Wasn't too serious a problem steering. We didn't have too much trouble staying in the zone. There, we were encountering features that we had defined by seismic and knew approximately where they were. All we had to do was drill through them, get to the end of the hole wherever we planned to go, and then we run 10, 15,000 feet, whatever there is of this stuff, one joint at a time, screw it all together, down the hole we go. Cement it in. Same deal we do every time. Pump cement down the inside, back around all the way. Lots of times they don't bring the production string back to the surface because you run out of time pumping the stuff. And there are even ways to have tools that out in the casing string that will open, allow you to pump a second string of cement if necessary. Adds to cost, complexity, more things to go wrong, but it can be done. Then all we have to do, let the cement set. If we know where our faults are, the features that we want to attack, we simply shoot holes in them. If they're sufficiently porous and permeable to produce gas, drilling's done. We don't have to frack. Sometimes they get cleaned up, a little hydrochloric acid. A little hydrochloric, 10,000 gallons. In fact, if this casing is 5.5 inches in diameter, which is a popular size to go down and around, if it's 10,000 feet long, it takes almost 10,000 gallons of fluid just to fill the casing. So we deal with big volumes of stuff. This went on for 3 or 4 years in the early 2000s. There's still an occasional well drilled in the Black River, but basically the industry moved on. Natural gas production soared in the Chemung County area for a few years as a result of this. At the same time, the Marcellus play in Pennsylvania got going. The application of horizontal drilling and combined with fracturing was found to be successful in producing the Marcellus. As you can see, the Marcellus is just a black shale. Bill Capel had some, if you were at his meeting the other night, just a black rock. Not very exciting looking stuff. We do exactly the same thing over the border in Pennsylvania. I've spent a good deal of time in Bradford County, but it's the same area, same game throughout. We start at the top, set our successive casings through fresh water. Down there, we actually set a double string of casings, which isn't required, but the industry has done that in an attempt to generate a greater safety factor, if you will, for lack of a better term. The second casing being about 1,000 or 1,200 feet long. First casing is typically as deep or deeper than any known freshwater wells in some radius, often half a mile or more from the well bore. They're all cemented in the same way. Marcellus drilling, once you've got your intermediate casing set here, 1,000 feet, whatever it is, the rest of the shales are pretty easy to drill. You drill to your kickoff point and go around the curve as far as you can go, depending on your lease ownership. If you look at these things in map view, there's there are some practical limits to drilling, but if you go straight away from a well pad, go straight down, straight away, you can go 10,000 or more feet, no problem. And when I say 10,000 feet now, I'm talking about what the industry calls vertical section. This is from the position of the well bore to the end of the well. That doesn't count the first mile getting down there. This is just the horizontal distance away. Once you get down here, you don't start producing until you get into the formation after you're pretty near or at the bottom of what we call the landing point. You're pretty well around the turn into the zone that you want to be in. Now, because this length can be long, somewhere between 3,000. Longest one I've ever been on was 8,400 feet. But the industry is capable of twice that if you own enough acreage. Biggest problem is, I shouldn't call it a problem, the constraining factor in a lot of this is how much lease land, how much mineral rights do you control that you want to drill. There are some practical limitations to how far you can go depending on how flat or how consistent this formation is. The problem being the drill string is quite thick. It's quite stiff. I mean, this stuff doesn't bend very readily. We can make it go up and down, but we only change a few feet in for every 100 that we drill. It's kind of like landing the space shuttle. You only get one shot. You can't stop and jack it up or down. You're committed. Get our lateral, whatever depth we're at. We then break the lateral up into segments. And when people talk about massive hydraulic fracturing, that's a bit of a misnomer, because yes, we're going to use a lot of fluid in total, but in each what we call stage, we typically divide the well bore up into 300 or 500 foot increments. And there's ongoing discussion, ongoing research as to what the optimum stage is. And they'll probably be discussing that as long as they drill horizontal wells and frack them. But at any rate, we then set out to frack, to stimulate a specific stage. We've got to isolate that stage in the well. We do that with packers, which are nothing more than a giant balloon that we inflate. We also can do it with baffles, which are nothing more than a retainer that catches some kind of a plug or a ball. We've got a number of gadgets to isolate zones, and they're dreaming up more all the time. We hook our pump trucks on the surface, pump our mixture of fluid, usually water. We pump down some sand. A lot of the frac sand used in shale wells is actually finer than this. We got to have some holes through this casing that we ran in here after we drilled the hole. We shoot the holes, isolate the zone, and frac it. Typical stage, depending on how vigorously you want to attack this formation, something on the order of 100,000 gallons. It can vary all over the map. It can vary from much less than that to more than that, depending on what you think you're trying to do. Bill Capel showed a slide from USGS research where they demonstrated that if you continue to pump on a zone and it found a wave weakness, it would leave the formation that you're trying to frack and usually grow upward. Pressure goes in the direction of least resistance. It doesn't care which way it's going, and whichever way breaks first, that's where it's going. Some of the frac jobs in the deeper wells, southern Pennsylvania, West Virginia, they've actually documented that it can climb as much as 1,000 feet. That's not a desirable thing. For number one, people worry about where it's going. Also, you just wasted a bunch of sand and water and energy and time fracking something that isn't going to give you anything to sell. The goal is to stay in this horizontal zone, in this layer of rock. And so the well is then fracked in successive stages all the way back till you're done. At that point, you wind up with a hole full of fluid. Sometimes they'll unload themselves. Sometimes you've got to go in here with tubing and blow some of the water out to get the gas. Gas wells flow by gas expansion. Pressure drive to the wellbore. The gas flows to the surface if it can overcome whatever pressure is in the wellbore. And so sometimes you have to get some of the fluid out of here in order to get the gas coming. All the mechanics of drilling, it's basically the same game every time. And this is the pretty standard procedure for horizontal drilling. The reason why the Marcellus was attractive in northern Pennsylvania was the thickness. I've brought along I've added some numbers here. 30 years ago, we looked at the Marcellus in Allegheny and Steuben and Chemung counties as a part of the Eastern Gas Shales project. I worked on about 6 of the 8 wells that were drilled back then. They were all fracked. They were vertical holes. We fracked the black shale. They all produced gas. Most of them didn't make enough gas to pay for the frack job, never mind the drilling or anything else at the time. But they did produce. We demonstrated that the process works. We just couldn't do it economically. And so that languished until somebody came up with a bright idea to combine the horizontal drilling, which exposes considerably more of the wellbore, to our ability to frack. Ideally what we want to do, you go back to plan view, we've got our horizontal wells drilled, excuse me, 1 or more. This spacing between wells is usually on the order of 600 to 800 feet. And we more or less want to maintain that spacing. The reason being, we believe in each one of these stages that we're going to propagate here, we can effectively produce cracks laterally about half that distance, 300 to 400 feet. In other words, we can go halfway to the adjoining well. If we go too far, we generate too much communication. We want to adequately drain. We don't want breakthrough from one well to another. We want cracks to go out here to allow the gas then to feed back to the wellbore. And that's our goal, maximize our recovery. So, pretty much standard procedure. In New York, we believe we can do the same thing in the Marcellus. We haven't yet tested it. Back to this map from the generic environmental impact statement. There's a line that shows up on this. I've highlighted it in blue. This is the top of the Marcellus being 2,000 or more feet below the surface anywhere south of this line. The reason for that is the state has decided, and this is an arbitrary line, but we've decided that we need our 450 feet of water stream protection going down. We want more than 1,000 feet of spacing between that and the top of any fracturing that we believe will happen. So we've arbitrarily generated this 2,000. This is proposed now for new regulations. This is not yet rule, but will be, or some variation of it will be, if the state decides to allow horizontal fracturing of shales. So as you can see, that basically is just the southern row of counties in New York. I'm telling you that over here the formation isn't very thick. The Marcellus, the Marcellus is actually divided into 3 parts. We typically frack the lower third. It's called the Union Springs unit, which is the bottom of the Marcellus. Steuben County, it's about 13 feet thick. South of Watkins Glen, it's about 44 feet thick. Get down here in central Tioga County, gets up to 70 feet thick. It's getting thicker going this way. Bradford County, Pennsylvania, 120 or more feet thick. So making the judgment that the thicker the formation is, the more gas or oil it's going to have in it. Where do you want to drill? This is the attraction for going south. I think that even if New York removes the moratorium and says, yes, you could drill, the only areas that will really be of interest will be Chemung, Tioga, and Broome counties. Now, it's thick over here too. This dark smudge is the New York City watershed area. So, politically you're not going there. It also happens to coincide with the Delaware River Basin. The Delaware River Basin is governed by, in part, by the Delaware River Basin Commission. There's also a Susquehanna River Basin Commission that deals with everything right here, essentially south of Newfield, is the Continental Divide. Water north of there flows north, water to the south flows south. Anything that flows south is in the Susquehanna River Basin Commission. They govern water usage, water withdrawal rates, and they regulate withdrawal sources, anything bigger than a residence. And the Delaware River Basin Commission does the same thing. They've gone on record as saying they're not going to allow drilling, period. Now, that may change, but it's not going to change anytime soon. So, basically, in New York, we're just dealing with this area as far as the Marcellus is concerned. Now, the Marcellus, when we drill a well, we log. I talk about wireline logs, that sort of thing. Got one along here. The little red mark, this is every 2 inches here is 100 feet. The little red mark up there near the top is the Tully limestone. That's the formation, that's the cap rot of the lower falls at Tagana. If you drive down Route 89, look at the lower falls, you're looking at the Tully limestone. That little hard layer right there that you can see right from Route 89. The Marcellus is the next blue layer down, where I've got the little blue stuck there. This incidentally is from just south of Watkins Glen, this particular well. Then we come way down here, just above the floor is the Utica. And everybody's heard about the Utica Shale. It's a little thicker than the Marcellus, not a lot. It's about half as organically rich. Now, if you look at the Marcellus, look at unconventional, what we call unconventional gas sources, there are a number of areas in the country where they are being explored, produced. This is South Dakota, the Bakken area. It goes up into Canada. The Marcellus and the Utica areas almost overlap, not entirely. The Utica extends farther into Ohio than does the Marcellus. The Utica is also present up in the St. Lawrence Valley. Up here it has been fracked in a few exploratory horizontal wells. It produced gas, but the initial rates were like 1 million cubic feet a day. That sounds like a lot. It's not. The rates we're getting down here are 5 or 10 times that initial open flows. So there has been some exploration of the Utica in New York. At this point, it's more of an unknown. We talk about drilling it. Most of us won't live long enough before we see very many Utica wells drilled in New York. And I'll come back to that in a moment. But there's a lot of rock between the Marcellus, which is relatively easy to drill, and the Utica, which is a little more problem. We got our salt section here again. We got to run another string of intermediate casing. A lot more expensive drilling, time consuming. In Pennsylvania, we've gotten to the point, it's almost unbelievable. Little rig sets the 20-inch casing. Big rig comes in and drills to the rest of the well from 100 feet to 10,000 or more, 12,000, some of them even 14, depending on surface elevation. Last one I was on was 11 days. And that includes setting 2 strings of pipe and waiting 8 hours for the cement to set. When you're drilling this stuff at 300-400 feet an hour, it gets pretty frantic if you're trying to look at samples or steer the thing. It used to take up to a month. I can remember working on a Black River well in Chemung County, I was there 60 straight days. We had some trouble. We had some drilling issues. It was not a trouble-free well. But the industry has learned to do things quite a bit faster and hopefully not sacrifice quality in the process. What that's done is reduce the cost, and that's necessary because along with this glut of gas, the price has gone down. Same thing growing corn, soybeans, anything else. Grow too much of it and see what happens to the price. Same problem. You're treating them as a commodity. In Pennsylvania, they're pushing 6,000 horizontal shale wells in the last 5 years, and they're roughly evenly divided between the northern area and the Pittsburgh area, which on this scale map is southwest corner. There's a scattering of wells in between, some of which have a little production history, some don't. There are 2 or 3 wells that were drilled just south of Olean recently. Pretty interesting to see what they produce. The reason being, the Marcellus around here produces what we call dry gas. Pure methane, or I'd say pure, it's 98% methane. Scrub out a little water vapor and you can put it right in a pipeline. In southwestern Pennsylvania, they can't. It's got too much what we call higher order hydrocarbons. Propane, butane, all the way up to crude oils in it. That has to be removed before you can put it in a pipeline. The reason being they liquefy too easily. And liquids in pipelines are bad. They put out pilot lights. They destroy compressors. If you're compressing a gas or your air compressor, suck a lot of water into it and see if you can blow the head off it. Same analogy. You got to get the liquids out of these pipelines. You got to create what we call pipeline quality gas, and that's typically 1,000, what we call 1,000 BTUs. Excuse me, 1,000 cubic feet contains 1 million BTUs of gas. Most pricing is based on 1 million BTUs of energy. The wetter gas has more BTUs. If you can burn it without having to move it very far, it'll have more like 1,400 BTUs per 1,000 cubic feet as opposed to per cubic foot. Got to watch the decimal points here. But in order to move it, to sell it, it's got to be pipeline quality. And so the stuff we have around here goes in the pipeline direct. Down here, you got to process it. Nothing wrong with processing because everything you take out is valuable. And it's worth $100 a barrel, not $3 a 1,000 MCF for what we, $3, $4, whatever we're currently getting for natural gas. So the liquids are now the current attraction because the natural gas, the methane, the dry gas by itself is just not worth enough to pay for all this drilling. Typical drilling cost to drill a 10,000 foot horizontal well, frack it, probably $3 million, maybe $4 million. That includes its share of the well pad and the road. That's part of the incentive, of course, to cluster these things. You can drill a pad and literally have 1 well per pad. That's what we did in the Black River. We found that if you drill off 1 pad, you may spend $300,000 or $400,000 building a 5-acre gravel pad, but that can accommodate a bunch of wells. I've added some here. You could add some more if you control all the acreage. If you don't control all the acreage, then the number of wells and the length that you can drill is constrained by your lease ownership. New York State has a rule as well that a drilling unit can't exceed 640 acres. So a couple of people have gotten creative and they've made each well a different unit. If they're a mile long, it's slightly under 100 acres. So there's creative ways to deal with that. But the Pennsylvania scheme, there have been units as much as 1,000 acres. You commingle all the production from whatever wells you drill. Most of the pads I've been on in Pennsylvania, we drilled 1 well and the rig went away. And it's like, that's not very efficient. Why are we doing that? Simply, they want to do that to hold the acreage. It's called holding the unit. And that's done because we really don't want to produce all this gas at present prices, but we want to hold this unit and the infrastructure so when the price goes up, we can go back and drill some more wells. This is one of the bones of contention of people that everybody has a different perspective on this. Some people want to produce all the gas now and get the check. Other people, there's people say no, it'll be worth more in the future. You make the same kinds of decisions buying and selling animals, farm machinery, you name it. You know, do you want to take the money and run, or do you want a longer revenue stream to last a lifetime or even longer? We don't really know the total life of what these horizontal shale wells are going to do. I've seen some of them that have been pretty well depleted in a couple of years of producing them at a maximum rate. Producing at maximum rate is not often desirable, not only from the money standpoint, but if you produce them too fast, you generate too much of a pressure gradient down here, you invite formation water in. Formation water is your enemy. We want to leave as much of it as we can down there. So there are pros and cons to producing them quick, producing them slow, operator type decisions, whether or not the pipeline will even take the stuff. So this is basically what the industry is doing at present. Bring that to, well, I should say a little bit about surface as well. When we set up a drill rig on this 5-acre pad, we've typically put down a couple feet of gravel. I was on a pad last fall where they bragged that they had set in 17,000 tons of shot rock for the road and the pad. Well, I don't know, I didn't do the arithmetic, but I'll bet you that's 500 truckloads just to get the pad built. Had to fix a mile of town road as well, and we've got a guy here who's going to talk a little bit about Pennsylvania roads in a bit, but had to fix the road before we moved the drill rig into the location because the road wasn't in very good shape. And you're basically bringing in over the road equipment. It's got to have a hard surface road to get in there. Typical industry numbers for traffic: 500 to 1,000 heavy truck trips per well. This is a big deal. After you build the pad, and the frac job after that can be another 500 truck trips depending on how big it is, because you've got to haul water in, haul some of it out, bring in a bunch of sand. Some frac jobs, the total job can use 500,000 pounds of this stuff. There's a lot of volume in all of this. Let me get back to my notes here a second. Some of the things that we need to point out, in New York State, in order to drill a well, you got to have a drilling permit. That's why the moratorium's in effect. Can't issue any drilling permits for horizontal wells until the moratorium is lifted. And included in that permit application is a requirement that you tell the state where you're going to get any water you're going to use and where you're going to dispose of it, if you're going to dispose of any, if you're going to reuse it. It's nice to project total volumes, but they're not that concerned about the volumes. It's the issue of what's in it. And you have to also tell the state what chemistry, what chemicals are going to be utilized in the frac job. One of my detractors wrote a letter in the editor saying there was an exception for horizontal wells. There is no exception. In New York State, any well for which you apply for a permit, you will tell the state what chemicals you're going to use in the frac job. You typically have the company, the specialty company that's going to run the frac job, provide that information to the state. That information is proprietary, some of it, and is not available to be foiled, accessed under the Freedom of Information Act, for the same reason that we have patents. A lot of the companies spend a lot of time on research. Research and development costs money. If that has to be disclosed to your competition, what's the point in doing the research? So that's been a bone of contention in fracking, but that's the way it's currently practiced. Now, we've talked about, or people have talked about gas and water wells. I've done a lot of water well work in central New York. I would estimate that the general public, is probably a better way to put it, can detect natural gas in probably 20% of the bedrock wells, the wells that produce water from bedrock in this greater area, naturally occurring. Everything from drawing the water, and it looks a little bit like Alka-Seltzer bubbles for a few minutes, to running it through a hose right out of the tap into a 5-gallon bucket and be able to light the top of the tap. Hot water faucets will spit at you occasionally. Some of them you can light, some of them you can't. Some natural gases are not flammable, but most of them are. So natural gas in water wells is a common occurrence throughout western New York, particularly where the shales exist on the surface. The darker the shales, the more likelihood the greater the likelihood that you're going to see gas in them in detectable quantities. As long as you're not smoking when you draw a glass of water, there's probably no harm there. You light somebody's kitchen faucet, it tends to get their attention. But it's a fairly common occurrence. If you look at one of the slides that was presented in Hector the other day about gas and water, it was measured in parts per billion. Now, my problem is I'm kind of old. When I went to college, we couldn't measure 1 part per million. But a lot of the research now is in parts per billion. I don't believe you could detect water physically looking at it, or detect gas in water physically looking at it, until you had at least several parts per million gas. And because it's lighter than air, lighter than the water it's in, it tends to effervesce and be lost to the atmosphere. In fact, that's one of the treatment methods. Put it into a tank, allow it to come to atmospheric pressure, and then repump out of that after it's had time to escape. Similar concept would be aerating a swimming pool kind of thing. Just remove the pressure so the stuff can boil off in effect. Now, in northern Pennsylvania, if you went to some of the talks lately, both Bill Capel and the Cornell professor showed pictures of fracking well sites that had pits. I've never been on a horizontal well where there was an earthen pit. We've done away with them in northern Pennsylvania. We contain all fluids and all cuttings in tanks. That's not a requirement. It's done just as a precaution to avoid any hint of contamination. In New York State, pits are still legal for drilling fluids and for the flowback from a frac. It's important you understand the definitions. After you put all this frac water in here, as quick as it's done its job and put the sand where we want it, it's now your enemy. We want to get as much of it as we can back out. Typically in a shale frac job, you'll get 15 to 20% of the total volume back in the first 2 or 3 weeks before you come to the point where you can shut the valve up here and say, I'm now ready to hook the pipeline up and start producing gas. You will continue to produce water with that gas afterwards. Not all wells do, but most do. The definition changes. The flowback water was that first 2 or 3 weeks, whatever it is, until you're ready to hook it into a pipeline. The production water is then the water that comes with the gas production. There's a reason, there's important distinctions in those definitions. in New York right now, I can flow back the water, the initial stuff, into an open pit. I typically have 45 days to clean it up under DEC rules. If it's the middle of the winter, they'll work with you on that, as long as you don't let it run over. I was on a well a couple months ago down in the Allegheny National Forest, down in here south of Olean. The federal forest ranger said if the water gets within 2 feet of the top of the pit, you're going to get fined. Make sure it doesn't happen. So you can blow it, and the pits are plastic lined, by the way. Similar plastic you could actually put in a swimming pool. We used to use 60 mil plastic, which is the liner they put under landfills. Most people currently, you can't even unroll the stuff by hand. It takes half a dozen people just to roll it out. Most plastic nowadays, 30 mil liner, adequate for holding fluid for a few weeks as long as you don't punch a hole in it. Not easy to punch a hole in stuff, by the way, without mechanical action. We also use the same plastic on the pad under the drill rig. We literally plastic an area as bigger than this room. We put a moat around it, roll the plastic up over the moat, and we basically have a 6-inch deep swimming pool. That's our containment area in case we spill anything under this drill rig while we're drilling or while we're fracking. The drill rig goes away, but while we're fracking, if there's any spillage, we want to contain it in this swimming pool. I can tell you they get slippery when they stuff freezes. And, obviously, if you spill stuff and it freezes, it's not very salty. That's one of the current bones of contention with produced water. There's not enough chlorides in it to keep it liquid on a cold day, which means it's not very salty. But we'll come back to that in a moment. So in Pennsylvania now, we're containing everything. We're trucking it off-site. We're not even burying the cuttings at the locations anymore as we do in New York. They're mixing it with, you dewater it, mix it with sawdust, truck it to the landfill. Believe it or not. Some of the landfills are in New York for the stuff from Pennsylvania, but any C&D landfill, any construction demolition landfill can take the stuff. Now, New York State, in looking, I'm jumping around a little bit. New York State looked at those loads of cuttings being taken to the landfill for radioactive content. And in the DEIS, it states that they found nothing above background levels in those loads of these fresh cuttings mixed with sawdust, roughly 1-to-1, and trucked to the landfills for disposal. Also, you will, however, in Pennsylvania see an occasional large pond that's been constructed to hold fresh water. And the reason for that is none of your water sources can provide the water that you need for drilling and fracturing operations at a rate at which you need it, when you need it. And so you've got a stockpile of stuff. Now, I've been to about 40 frac pads in Bradford County, Pennsylvania. None of them had more than storage for 1 million gallons, tank storage. And there were no pits. A couple of them were close enough to a pond where, yes, somebody could have laid a line over to these larger ponds and pumped from them. I didn't see that, but I'm not there during the actual frac jobs. So basically, the industry nationwide says the average frac job is using something like 4.5 million gallons. We're not seeing that up here in the dry gas area. They're using the bigger frac jobs, southern Pennsylvania, Ohio, and in the farther western part of the country, all these various other shale areas where a lot of them are deeper. Some of the laterals are longer, some not. In 2011, according to the state of Pennsylvania, 97% of the frac flowback water, the frac return water, that stuff that comes back in the first couple of weeks, was recycled. Why? it's gotten too expensive to get rid of it. When we used to drill vertical wells around here, you wind up with 20, 30,000 gallons of water in your plastic lined pit. You have water trucks haul the stuff away. Typically goes to the local sewer plant. Sewer plant has to have permit capacity to accept it. You can't exceed their discharge limits for chlorides, anything else that's in there. And I'm not going to try to tell you that we analyze for everything that's in there. The main thing with sewer plants is pH and chlorides. They're easy to measure. You don't want to take them below to acid. Incidentally, you'll hear a lot about acid in frac jobs. I've argued for decades that the acid doesn't do much good. But you know, it's a little bit like buying a new car. The salesman wants to sell you a warranty. Well, they sell the acid the same way. Well, you need the acid in there in case something might happen. The acid, typically hydrochloric acid, is there to dissolve any cement fragments that may be in these perforation holes. And it'll also dissolve any carbonate material it encounters. The unfortunate part is there isn't a lot of carbonate material down in here. Guess what happens to the acid? You get a bunch of it back. Somebody calls you up and says, why is my flowback water or my production water got a pH of 4? And it's simply unspent acid. And there's no point putting it in there if it doesn't do you any good. But that's where I differ from the mainstream in a lot of the fracking. It's so bad, I've had frac companies refuse to hook up to a well, vertical well now, not a horizontal, but a vertical well, unless we put acid in the well. So I said, okay, we'll put in the minimum necessary, 50 gallons will do. We used to put in 500 gallons in 4.5-inch casing. 4.5-inch casing holds less than a gallon to the foot. That means I've got over 500 feet of acid in this well, and I've only got 50 feet of perforations down on the bottom that I want to clean up. But anyway, it's cheap. I fracked one time without acid when they made a mistake and left the valve closed. Job worked fine. But anyway, okay, moving on here. As I said, the return water is too expensive to get rid of. You got to haul it anyway. Take it to the next job. There's economies of scale in all this. You typically don't drill one Marcellus well at a time and not go to the next one somewhere, either on that pad or another pad. I think the term industrialization is inappropriate in a lot of ways, but it's been used, and it's a catchy phrase where it implies that you just go from one to the next and you do the same thing every time. One of the magazines made a comment here a while ago that there's been so many horizontal wells drilled in the United States now, they're taken for granted by everybody but the poor schnook at the rig that's trying to land the thing. In other words, the guy that's trying to steer it and get it in the right spot. Every one is its own distinctive little problem. And the goal is to get in there, because if you're not in the formation, you're not going to get anything back after you frack it. If I drill, we have to talk about spacing. One of the issues that a number of people talked about. If we set up a drill rig in Bruce Ostick's front yard, he drills a mile-long lateral toward my house, and I set up a drill rig in my front yard and drill toward his house, mile. Same deal, vertical section, a mile. How far apart are our houses? The answer in New York is a minimum of 2¼ miles, because under New York rules, I can't go closer than 660 feet to a property line. In Pennsylvania, you can. Believe it or not, a Pennsylvania Marcellus well can go right up to within 10 feet of the property line, because it falls under rules that were generated 100 years ago dealing with the oil fields. In New York, unless the legislature acts to change the rules, or actually I guess DEC can change it by rule, but I don't expect them to. My point in that is a number of people have written letters to the editor and so on saying that wells are going to be all over the place. In the direction you drill, they're going to be, the pads are going to be at least 2¼ miles apart. I don't believe you'll see very many laterals less than a mile long, simply because you're not exposing enough formation, especially if the price of gas stays low, to make the whole thing anything near economic.
What about the other direction?
The other direction depends on how many wells you got on the pad, how much acreage you control. If they're 800 feet apart and you've got 4, you're about 3,000, a little over half a mile. This is assuming that you own all the acreage. So that'll give you a scale of how many pads you can put in a given area. The reality is you rarely get, if you're getting the better part of 8 wells per pad, you're rarely going to have more than 1 pad per square mile, because you got roads, you've got acreage that's not included for whatever the reason. You never lease everybody. Now, forced pooling is another one of these naughty terms that pops up. That's not a gimme. It can be done where a company controls 60% of the acreage, but it's a legal process. They have to give what we call the holdouts, the landowners that don't participate, the right to participate, the right to sign leases after the unit is created, and then only then, if they refuse to participate, they become forced pooled. When you're forced pooled, the gas company has no right to come on the surface. They have the right to withdraw gas under the surface. This goes back to the preamble of the law. The law, New York State Conservation Law, says it's designed to prevent waste of the resource. Waste inferring maximum recovery, not our present use of conservation, which is basically don't touch it. When I went to high school, conservation was the wise and careful use. Now it's evolved to the point where it's off limits for production. So, and then what I tell people, quite frankly, if you're in a situation where you're facing forced pooling, sign a lease and assign it to your favorite charity, the SPCA, whatever. You know, the well is going to, if the gas company has control of sufficient acreage to create the forced pooling situation, instead of stomping your foot and saying no, put your share of the royalty to some use. The royalty's held in escrow. If you don't do anything with it, it'll sit there dormant. I'm sure, like bank accounts and everything else, it'll eventually revert back to the state if you don't use it for some other purpose. I suspect that law will probably be revisited again. That's new. That went into effect only in the last 5 years. Prior to that, there was no forced pooling. You either owned it all or you went around it. So
that's when America actually existed.
What's that?
America actually existed, when you couldn't force someone to sell something.
Well, forced pooling's been in effect in Oklahoma and Texas.
Compulsory integration, not forced pooling.
Well,
use the correct terminology.
Yeah.
It's legal term.
Yes.
That's legal.
Talk to your lawyers and politicians.
Okay, another issue has been pipeline development and construction. Pipeline construction is regulated by the Public Service Commission in this state. There are 2 primary categories of pipelines. One are what we call transmission lines. They typically operate at more than 124 psi. Gathering lines typically operate at less, not always, but frequently do. They have minimum depths of burial. If you're in the business of building pipelines, you want to bury it where somebody can't hook it with the field cultivators or deep chisel plowing or whatever else you're doing. Otherwise, you don't tend to get what you want out the end.
Are those forced by eminent domain, sir?
I believe transmission lines can, but not gathering lines. Typically, gathering lines would fall under jurisdiction of the lease. Most leases convey the right by mutual consent or some language that says gas pipelines can be laid on this property. Some leases refer to only gas produced on that property. Some refer to gas from in the unit or off-site. There's different languages.
So there's no eminent domain, are you saying?
As far as I know, not for gathering lines.
Or what kind of lines?
Transmission lines which are deemed to be in the public interest, and you would have to get a certificate of need from Public Service Commission. And the point in that is that, in the same legal idea here, right or wrong, whether you like it or not, is that some smaller landowner can't prevent some larger entity or individual or whatever from doing something. No different than erecting a toll gate on the road or whatever. You need to create the public need. You establish the need from the government's perspective that this is a desirable entity. Same way you do for roads. If you're going to.
And since these are foreign corporations invested in the gas that's taking it out, how is that helping Americans?
That's not addressed in.
I'm asking you though.
Well,
You're representing your
let's
industry.
hold off a minute. Let me go through a few more of the nuts and bolts, and then we'll talk about the philosophy here a little bit, if you like.
It's over an hour, like an hour and 20 minutes.
Am I getting?
Yeah, you're getting
rambling now?
long-winded. Yeah, you're getting
I've been known to
long-winded.
do that. One of the points I want to make is that Don Barber, when he spoke at Ovid, talked about the difficulty of regulating drilling operations under zoning, because Cornell University has some construction projects that are as large or larger than most drilling operations. I'd like to take that a step further and say that drilling is a construction activity. And the reason being, it ends. As I said before, the drilling phase now can be somewhere as little as 2 weeks, probably more likely 3. The drill rig goes away. Now, prior to that, we had a pad. When Bruce built this building, I'm sure he spent a little time grading it off, compacting, a few loads of gravel to get this thing built. The gas well, the pad is simply bigger and has to more or less carry the same kind of loads. A construction project ends at the end of the frac job. The production of gas is no different than the production of electricity from a windmill. If you've got, I was standing under some windmills a couple of weeks ago in Wyoming County, big windmills, the big ones. And there's a hard surface road, all-weather road. A little pickup drives up to that windmill every day to check on it, service it. And there's a pipeline. All of the electric wires are buried from one windmill to the next, and they're gathered, very similar to what we have once we complete the pipeline for natural gas delivery. I see many parallels, good or bad. So, in my argument, my presentation, my theory is that you treat gas well development as a construction project because it does end. The production of gas from one or more wells on a pad may last for decades, depending on how it's produced. There are wells in Erie County, New York, I've seen some approaching 100 years old that are still producing. I don't expect that from shales, but shales have a tendency to produce gas at relatively low rates for long lives. Now, that in itself is a problem. A number of people have argued for moratoriums.
Or bans.
The problem with a moratorium is it's for a set period of time and it's renewable. While you've got your moratorium, or while you're studying, state of New York's already spent 4 years. The typical gas well in the United States declines at between 12 and 18% per year if it's produced at something approaching its maximum rate. Horizontal shale wells, as near as we can determine, produce about, decline at about 50% per year for the first 2 or 3 years. Why is that important? We're going to have you down to a low rate if we want to keep the pipeline full. Well, right now we've got a glut, so we don't need more gas, but there's quite a bit of lead time here. If you want to keep the pipeline full long term, you've got to continue drilling. If you stop drilling for even 2 or 3 years, you'll see you will build in a pretty substantial price increase because you'll create a shortage in the pipeline, if you will, down the road. At this, okay. Another item is traffic. I've already alluded to the fact that drilling is 500 to 1,000 heavy truck trips for just the drilling, additional trips for the construction. To put that into a little bit of perspective, a lot of large dairy farms take a milk pickup every day. There's 365 a year. So I don't know how many heavy trips you would have to a large crop farm, but I'm sure it's quite a few in the course of a year. The road doesn't care; the weight's basically the same. At any rate, at this point, I ought to stop. And,
Please do.
Let Tom Shetstone speak for a few minutes. If I'm running long, I probably better be quick after he gets done. Tom is affiliated with the Energy in Depth group in Pennsylvania, runs a Marcellus website, and I haven't previously heard him speak, but I'll let him do that at the moment.
Okay, thank you. I'll be brief. I know a number of you want to ask questions and things of that sort. First of all, let me just talk a little bit about the road impacts, because that's something that Brayden asked me to address a little bit. And I've done, just a little background on me, I'm actually a landowner myself in Pennsylvania. I actually own property right about here in that DRBC region he's talking about. I leased my land back in 2008. We're still waiting for the DRBC to come out with regulations on that. And I got involved in this. Excuse me?
You could speak up just a little bit.
When this warms up again, and I'll shut this off.
It's a little closer.
So in 2008, I leased my land, and I'm waiting on the DRBC for the regulations. The reason I got involved in this industry is I have a consulting business, and I've been working in both New York and Pennsylvania for several decades, doing work with communities like the town of Covert, not this particular one, but various towns. And I've done a lot of work in counties, including Yates County and Schuyler County and a number of others, Steuben County. And I got involved with the gas when I signed my lease, and I became concerned because of the way things were going politically on this, and I became involved, kind of working through my consulting business and on a personal level. And along the way, I got hired by Energy in Depth because they saw what I was doing and asked me to get involved. So I've been representing Energy in Depth, which is an industry-sponsored organization, so let there be no doubt I'm here speaking on behalf of industry as to this industry and its impacts. However, I also speak as a landowner. And one of the things that we've done with our Energy in Depth program, and we cover both New York and Pennsylvania, with what I'm involved with, and I have with me Rachel Powell here someplace here tonight, who's helping me. And what we've done is we've gathered a lot of data. We've tried to provide a lot of information to the public about this industry and what it involves, and correct a lot of the myths. And one of the things that's most important to me is the economic impacts, and also looking at how the economic impacts that might be negative compensated for. And one of the things that Brayden brought up, of course, was the road. Are there road impacts? To be sure, there are road impacts. However, the industry has put several $100 million, probably in northeastern Pennsylvania, probably over $1 billion into road improvements. And most of those road improvements have been made prior to gas drilling. So you can go into various communities in Bradford County. I spoke to a supervisor there probably a year and a half ago at a meeting, and he was pretty pro-gas, but he wasn't extremely pro-gas. And he said to me, he said, you know, to be honest with you, he said, I was concerned about this, but we would not be able to have maintained our roads and brought them up to the condition they're in today had we not had the gas drilling, because Chesapeake, which was the primary company operating in that area, was able to invest, again, millions of dollars into upgrading their roads. And I see that. I see that in various areas of northeastern Pennsylvania where the road conditions have improved as a result of gas drilling. Is there truck traffic? Are there delays? Are there temporary inconveniences? Are there situations where roads are damaged and have to be repaired? Yes, of course. All those things do happen. However, the net effect of that is an overall improvement in roads. And I'd be happy to take any one of you to a tour of northeastern Pennsylvania and show you instances of that. And one of the ways you do that is through road use agreements. Road use agreements are an alternative to the bonding approach. Communities in both New York and Pennsylvania have the ability to bond roads, to set limits, weight limits and things like that, and to require people who exceed those weight limits to post bonds for damages. You can do that. That's perfectly legal to do that. The problem is when you do that, you're going to run into conflicts with other vehicles, such as milk trucks, for example, and stone trucks and things of that sort. And most people don't want to do that. So the way to get around that, and it's done for both, and I've represented wind companies, by the way, too, in project in New York State and Pennsylvania. And it's the same technique for both gas and for wind projects. You make a deal with the community, essentially up front, to say, we're going to evaluate the standards of that road before we proceed. We're going to document what the conditions are, and then we'll compensate you for any damage. Or, and a better situation is, we will improve that road to a condition that we can take the traffic that we're going to put on it prior to doing it. That's the proper way to do it. And then to make any corrections after the fact if there are damages. So that's what you do. And there are many models. It's not something where you need to reinvent the wheel. There are many models and drafts out there. You can pick and choose. And you always have the ability to do the bonding thing as leverage. So if you're trying to say, well, how are we going to get a company to do it? Well, you have the ultimate leverage. You have the ability to post the bond. But what you really want to do is get that private agreement, because you're going to get a lot more out of that at the end of the day. And virtually all the companies that I know, all the companies, not virtually, all the companies that I've had any doings with have been very amenable to doing that, and there are multiple instances of it. I'll just mention very quickly a couple other things, because we did some analysis of data. One of the things I do is a lot of economic impact research for various things, such as, for example, in New York State, I did a study several years ago on the economic impact of the deer farm industry, for example. And one of the things we look at when we look at these kinds of things is to look at data from the Bureau of Economic Analysis. And we looked at data for Elmira, and we looked at Bradford and Susquehanna, which is essentially Towanda and Montrose and that area. Bradford and Susquehanna are the two big producers, as Brayton said, in the northern tier. They're not the only ones. Tioga and Lycoming are also big, but those are the two big ones, okay, that really produce the gas. And these counties, if you notice, the borders are just about the same. They extend the same area. So you're looking at the two sides of the border, the twin tiers. You're looking at the southern tier in New York State, and below that, the northern tier in Pennsylvania. And we looked at the data. And I have a presentation that includes several charts. But let me just mention a couple of key statistics. First of all, when we look at the number of employees, give me a second here till I get to that. Okay. We looked at the employees from 2001 to 2011 in those areas and compared them. In the New York State side, on the southern tier side, those counties over that period lost 13,000 jobs. While the two counties on the Pennsylvania side, which are much smaller population to start with, gained 1,645 jobs for an increase of 5.2%. Now that's over a 10-year period. Then we look at wages. On the New York State side, these three counties, the wages from 2008 went down 1.2%. On the Bradford and Susquehanna side, on the Pennsylvania side, they went up simultaneously, again, from a much smaller base, by 28%. And when you compare the numbers, the actual numbers, New York State lost about $70 million in wages, while those two little counties in northern Pennsylvania gained $278 million in wages. That's what this industry does for an area. Now, Braden has gone through, I think, very professionally what this involves. And I think he's given you a very, I think, pretty neutral perspective on it in terms of what it involves. And I think it's very good. The bottom line is, that when we look at this from a nationwide perspective, across the entirety of the United States, there is not, and I know there's a lot of people trying to assert otherwise, because they're trying to use fracking as a term to cover the entire industry. But the truth is, hydraulic fracturing has never polluted a water supply in the United States. It has not. You can laugh all you want, but that is a documented fact. That is a documented fact, attested to by several states, by the EPA. That is a fact. That is not correct. It is a fact that there is no water supply in the United States of America that's been polluted by hydraulic fracturing. Now, have there? Well, let me answer what I know you're all going to say. You're going to say, well, there's this spill, or there's that, or there's this. All those things have to do with natural gas development in general. They do not have to do with hydraulic fracturing. And what we have,
but the drilling has polluted. What about the drilling?
Let me talk, will you please?
Wait a minute here.
I'm going to shut up in a minute.
One at a time.
Let me answer. What you've had as a result of the movie Gasland is you've had people conflate they took that flaming faucet, which was a lie, by the way. That fact that Colorado State said that had nothing to do with gas drilling. Nothing. And what happened was that he took that and presented an image in the public's mind that somehow that was a result of hydraulic fracturing. It was not. It had nothing to do not only with hydraulic fracturing, but nothing to do with gas drilling. And that's where we started down this road. Now, I see Craig holding up that jug. Now, let me tell you something. Dimmick, he comes from down near Dimmick. That jug, which his buddy held up all over the place, and he's held up everywhere.
My buddies, that's Ray Kimball's.
Well, whatever. It doesn't matter. That water has been tested. The Sautner's water, which they ran around with that jug everywhere, that was tested by the EPA. And that water turned out to be safe. The EPA came in. The EPA tested that water and found that it was safe. That's the bottom line. The EPA tested it and found that it was safe. Now, at that, now that we've got it sprouted up a little bit, we'll turn it back to Braden.
Okay, good. Okay, if you want to bear with me for maybe another 10 minutes, I want to run through some of the other items, which some of which can be equally contentious.
Take some questions.
Give me about 10 more minutes, and then we'll have some questions. How's that?
10 more minutes? Are you kidding?
Wait us out.
One of the issues has been radiation, naturally occurring radioactive elements in the black shale. If you look in the environmental impact statement, the draft environmental impact statement, the state of New York tested some of these loads that were going to the landfill with a Geiger counter. They also tested samples in the state's repository, it's in Rensselaer, as well as some outcrops. And it states, I can read from the environmental impact statement, that there were levels essentially equal to background values that do not indicate any exposure concern for workers or the general public. I'll go further than that. The Marcellus Shale, as you can see by this line up here, outcrop extends all the way across the state. In the town of Fayette, when you're standing in your field looking at the black shale, you're standing on the Marcellus. All the creeks up there, even all of the lakes are in contact with the Marcellus Formation. Now, one of my detractors wrote in a letter to the editor that the formations on the surface are not the same as the formations at the same formation at depth. I want to take issue with that. They are. There are a few subtle differences. One of them is the radioactive element radon. The reason for that is radon's water soluble. It's one of the radioactive elements that shows up in what we call the production water that we get over time from the Marcellus Shale, presumably also from the Utica, although we don't know that yet. The production water does have elevated levels of radioactivity. Apparently in Pennsylvania, somebody said that they have open pits of production water. In New York, that's been illegal for at least 20 years. All production water has to be contained in a tank and disposed of by a licensed hauler. Most of it is trucked to Pennsylvania for disposal. Most production brine in this area is not salty enough to be used for road spreading. There is some in western New York that is, but most of the production brine in this area is not. In fact, brine is probably a misnomer. It's salty, but not a good heavy brine for dust control and for ice control. In New York State, by the way, if you're going to road spread any kind of salty fluid, you have to have a permit that specifies the roads on which they're spread. You just can't take off and spread them. In New York, we also have, we only have 2 disposal wells that take production brine. My personal opinion, that's the place to put it. Put it back where it came from. However, in New York, we do not. Depending on whose numbers you want to believe, there are between 40,000 and 155,000 disposal wells in the United States for production fluids. And I think the state of Pennsylvania has a dozen or something like that, which are commercial. State of Ohio has a bunch. Midwest, Southwest is where the bulk of them are. I think we will probably, if we go forward with Marcellus development, probably entertain the development of some here. My personal opinion, that's the place to put the stuff. Put it back where it came from. That's an opinion. Going forward, there have been about 6,000 wells drilled in Pennsylvania for Marcellus Shale. That glutted the market. If drilling continues elsewhere, how many wells do we need, even if we open up New York, to gas well drilling to keep the pipelines full? If we don't do any large amounts of exporting, which isn't going to happen anytime soon, but could ultimately happen, you probably need less than 1,000 Marcellus wells a year, New York and Pennsylvania, to maintain present levels of usage. If you get into conservation, use less, promote solar, wind energy, whatever, the demand would be less than that. There was a slide presented last Thursday night regarding Shell Oil Company has a large lease position in Tioga County. That lease position could keep the pipelines full all by itself for a number of years if it were fully developed. And in a situation like that, I believe they're willing landowners. And quite honestly, whether New York produces gas or not, the industry will survive. But some of the landowners may have some difficulties because all of this ultimately comes back to money. Why would you lease if you don't need money? If your kids' education is secure, your grandkids can go to college of their choice, you got plenty of money, why lease?
Greed.
Yeah, money. You lease, most people lease with the expectation of some kind of financial return. And so, I believe in a free country you ought to have the option to do that. Now, that doesn't mean that I can do something that will impact my neighbor. That's why we work at creating redundant systems. And as Tom pointed out, the problems are not in the well. I've actually recovered casing from 2,000 or 3,000 feet of depth, pull it out with a drill rig. Been in salt water for 20 years. There's no oxygen down there. The stuff comes out like it's brand new. You can still see the chalk marks on the side of it where we numbered the pipe. It sits on the rack 2 days on location. It looks like this. The the presence of oxygen is what creates the corrosion problems. And because mankind is involved, we're the ones that spill stuff. Most of the problems and the contamination of water wells, if they in fact exist, and there are some, have all occurred from spilling stuff on the surface. And I proposed in my letter to the editor of the opinion piece there a couple months ago that we have lake-friendly gas well sites, just the same as we have lake-friendly farms. I got the idea driving down Route 89. There's a sign in front of one of the wineries. Believe it or not, I opened the computer last week. There's a group in West Virginia that just made that deal with Shale Oil and a number of operators down there. They're going to create an independent group to review their drill site operations, a voluntary program, to create some credibility, if you will, for their operations. And you know, quite frankly, the best way to avoid an environmental problem is don't have anything there that's going to be an environmental problem if you spill it. Mercury and lead are good examples, but there's lots of others. Wells can be fracked with biodegradable materials. Why don't we do it? Because the chemicals that we've used are cheaper. But as has been pointed out, the chemicals are there to reduce friction, so we can pump the fluid easier, less horsepower. And the chemicals are also there to help carry this stuff so we can get it where we want it. And I maintain that once you put them here, other than the part that flows back, they're going to stay there. They're going to stay there for the same reason the gas stayed there for the last 300 million years. It's confined. And so the problems are on the surface. If there are problems, they're on the surface. So, the flip side, I guess the last thing to say here is, actually the last thing here, believe it or not, is to tell a little story. My great uncle lived at the mouth of the Black River by Watertown. 1903, I'm not sure the exact year, but he told the story. The first gasoline-powered motorboat on Lake Ontario came for a visit. They knew it was coming. The village fathers were so afraid of that boat blowing up and burning up the town, they made him anchor out in the middle of the river and they sent a rowboat out to get him. I told that story to a couple of people here a year ago, and they said, oh yeah, it was like that when rural electrification went on around here. Now, I'm not old enough to remember that, but I was telling that to a person who was, and they said, oh yeah, there were a lot of people like that. It's almost some identification with things you're familiar with. You know, is electricity perfectly safe? No, people get electrocuted now and then. The most dangerous thing I do is get in my vehicle and drive to the drill rig. Once I'm there, accidents can happen. The workman's comp rate on drill rigs is about the same as it is for farming. So, you know, accidents happen, people get hurt. As a geologist for the last 30 plus years, I've been in the business of fixing things. I have to identify things and so on, but I also have to fix things. Fix problems, solve problems, and I believe the technology that created all of this can solve the problem. Will there be problems along the way? Will there be sites that get contaminated, whatever? Sure, look at Seneca Ordinance. There are parcels on the ordinance that have been. Everything comes with some risk, no matter what you do. And if we can manage the risk, the grapes, the lakes, the gas wells can all get along.
Hey, Brayden, can I say,
Yeah, I'll feel
can I
some.
say one thing?
Sure.
When we're talking about the trucks on the road, I heard people chuckle about how many truckloads. I'm going to incriminate myself here. So actually, off of this farm, I was thinking about there's probably 800 loads in, 800 loads out, and probably 200 or 300 loads of material coming in to grow the crop. So this farm alone will be over 2 to 2,000, 2,500 truckloads of material a year. That's every year for 40 years. So, you can
Well,
chuckle, but
and,
it's a lot
and
of
those,
material
and those
goes in.
trucks, and those trucks pay highway use tax.
Well, I don't want to go into the figures. I tell you what.
No, but I mean, they pay use tax for the privilege of using
Pay
the
a lot of
public
money to run the
roads.
truck.
Absolutely.
You pay 50 cents a gallon just for the fuel tax. And I don't know how much it would be if you figured out, but it's hundreds of thousands.
In case anybody doesn't know, this is Bruce Ostick, our host here tonight, and we certainly owe him. Making this possible. I'm going to field some questions here in no particular order. I'll work my way this way and back and forth. John?
Given the blue line that you have there and the fact that Seneca County is considerably above that, what's the likelihood that we're going to see very much in the way of horizontal fracking in this
You and I
area?
probably won't live long enough, unless something radically changes. I don't believe the formation is thick enough here, and it's too shallow, I believe. Based on what we know today now, technology is advancing, we don't have all the answers, no question.
Sir, you did a good job on the well stuff there. But you have to actually talk about what happens above that, actually people. And you have some sand up there, but that's not actually the sand that's used in hydraulic fracturing.
Oh, yes, it is. This is right out of the Halliburton.
That's silica sand?
That's right out of the Halliburton truck.
Is that silica sand?
Yes,
That is silica sand?
yes.
Oh, open up and take a whiff of it. Because for OSHA, their requirement is that you have a full mask on with goggles to work with silica sand, which is going to be needed by every farmer in here and their animals to prevent lung cancer caused by silicosis with silica sand.
Don't forget when you.
Is that true or not true?
This
Is
is
that
a.
true or
This
not?
is.
It's a simple question, sir. Is it poisonous sand or is it not?
It's not poisonous. It's
Causing lung
capable of
cancer is
creating
not poison.
silicosis. Yes.
It causes silicosis, correct?
It's capable of it. Yes.
It's capable of causing silicosis, which is lung cancer, right? So
I'm not a medical expert, so I'll refrain from that. But
Okay, I think people got the answer.
but no, just remember what silica sand is. When you shovel sand out of a gravel pit, you're shoveling up approximately the sand fraction will be at least 80%
We're
silica.
talking about particulates that you can't see that cause holes in the lung once you
Oh yeah,
breathe it.
no, silica is ubiquitous.
Just so everyone in here understands what you're using on their property that they can never say no to.
If this is your worst problem, you don't have that.
No, you don't do.
What is our worst problem?
This is not business.
Not the oil business.
How about the gas business?
They're the same.
Too much in the home.
Thank you guys for coming and doing the presentation. I'm from Breck County and I would like to know how, you were talking about leasing a little bit, and I was wondering for up in New York State, how does the language differ from the leases that we were offered? Because I was wondering, will the gas company in New York State sign a lease that states that the landowner is to receive all royalties based on the highest point of sale? What I mean by that is, we have seen royalties coming in that are based on the sale at the wellhead, but we also know that gas companies are paying royalties based on hedge point, which is $6. We also know that they are capable of paying on the line at the marketing price, which is $18 MCF. So in New York State, I was wondering, will a gas company sign a lease that has language saying that the royalties will be derived from the highest point of sale?
I don't know where you're getting $18, but we'd like some of that. And I can't speak for gas companies. I don't represent one. I work for them. The leases should be. There's one other issue in leases as well that's even more important, and that's the lease royalty should be calculated on the gross receipts from the sale and not some of this language that says after taxes, after payout, etc. Even if it's only a 1/8 lease, you want to be 1/8 lease. Most leases that I'm familiar with, and I'm not an attorney, state 1/8, 12.5% of the gross at the first sales point. Now, there is a company running around Western New York that wants to pay the royalty on the net revenue. You never want to sign any kind of a contract where your payday depends on somebody else's bookkeeping, and I don't care whether you're selling gas or soybeans or you name it.
Well, is that the language that is kind of talking about, see, in our area, we have Chesapeake operating, and they just created a company called SEMI, which is Chesapeake Energy Marketing Incorporated. So what we're seeing is Chesapeake is selling to themselves, and our royalty is derived from that. So they're selling themselves.
Is that the first sale? Is that the?
So what happened is, what I'm asking you is, so they're selling to SEMI $1, and our royalties are derived from that dollar. It's 12.5%. And then you add the minus production costs and all that, because some of the people have bad leases. So what I was going to ask there is, just talking about the net and gross and all that, is it in New York State, is it illegal to sell or receive royalties at a second party sale or a third party sale?
It wouldn't be illegal because a lease is a contract. Again, I'm not an attorney. You need a better opinion than mine. But as I understand contract law, whatever is specified in the contract in terms of the sale point would be what you receive.
Well, some states have stepped in and said, look, because of the taxes and royalties, we want our landowners to receive from the third-party sale, so therefore the gas company cannot sell the gas back to themselves at a second-party sale.
I'm not aware of any language to that effect in this state, but again, I'm not.
No, I mean, okay, I was just wondering if New York State was prepared for that or not.
Typically in New York State, the only thing I can tell you about that, typically in New York State, the first purchaser submits a report to the state as to what they purchased, and that's called a purchaser and takers report, and the producer generates the same report. As far as the revenue, that would be dictated by the terms of the agreement. I don't believe, I'm unaware of any contract language that would require a higher royalty rate or something of that nature. And it's an issue because lots of people receive. Yeah, you're defining the point of sale. Yeah. To my knowledge, like I say, I'm not an attorney, so somebody else would have to speak to that. Yes.
Thank you very much.
Hi, my question is also about leases. My husband and I signed a gas lease before we knew about fracking, and we did take it to our attorney, who at that point knew nothing. And we came to realize that we'd made a big mistake, that the language in the lease was totally favorable to the gas company in a lot of ways. And I would just urge any of you who are considering leasing to be very cautious. If you're thinking of signing a lease, you got to remember it is an industrial process. It will have some risks. And what a lease can do is it can't prevent harm. It can give you the legal rights to sue them if they create harms that you've tried to protect against in your lease. But suing one of these big corporations is not anything to be taken lightly. What happens if, and it does happen, they use a part of your land that you told them they couldn't use. You're going to sue them. What happens if they don't maintain fencing so your animals get into something, or your neighbors get into something? Are you prepared to sue them? What happens if your well gets contaminated? And regardless of what Mr. Shepard said, there have been well contaminations, whether they're caused by the fracking or spills or whatever, there have been. Even then, sue them, but that doesn't fix your water. So I just am urging you to be really cautious and think about it. And there are some publications. This thing just has a whole lot of questions that you need to ask yourself. How will you get enforcement of the provisions of your lease if you're able to write a lease that's a good one? And I guess my question would be to the two of you, are you, as far as I know, the Joint Landowners Coalitions are trying to put together a good lease, a lease that has a lot of provisions in it to protect. two things. One is the landowner coalition, lawyers, and leaders, they make money only when the lease is signed. So their interest is to get a lease signed. So you have to be pretty, you know, a little skeptical. And the other thing is that
well,
so basically my question is, are you aware that any leases have been signed that you think are protective of the landholders and the environment? I don't think any of those have been signed.
Not in so many words. My experience in Pennsylvania and in Western New York, most gas well operators try at least reasonably to protect fences, protect tile lines, protect roads. There are always people who are disgruntled, unsatisfied, dissatisfied with whatever they got. And I'm sure that goes far beyond the oil and gas industry. There's lots of litigation that involves lots of trespass and arguing in construction industries and probably farming and everything else. So, sure, a lease is a contract. You should read the thing. If you don't understand it, get some advice. I tell people, X out the renewal clauses, X out the storage clauses. And the reason for that is I want you to come back in 5 years or whenever the end of the primary term is. We'll renegotiate another bonus because I don't really care whether you drill on my property or not. Making the judgment, I don't think there's too much gas around here. I'll take the rental money, which is a sure thing. And if the drilling happens, fine. If it doesn't, fine. That's my personal philosophy. Let me grab a few.
Let me just add, I want to add to that a little bit, because I represented a coalition, like an informal group that I was in. And I would just say, you know, you need to operate as a group. You know, that's what you need to do. You need to work as a group. And we, in our case, I'll just mention, we added 23 addendums to the lease. We took the standard lease. We did exactly what he said. We X'd out a bunch of things. And then we added 23 addendums that we wanted to that lease, which addressed things like fencing and all that stuff. So that's what I recommend.
If there was a violation, Tom, if they didn't obey what they were supposed to, does the lease that you signed say who's going to take them to court?
Yeah, there's an arbitration clause.
Arbitration, I've been told, is terrible.
Well, what you want to do is make sure the arbitration occurs locally, not in Texas.
But sir, they can turn around and sue you too.
How about bonding? How about landowners requiring?
You can do, I don't want to get too into it because I'm not a lawyer either. I can just tell you that the thing you should do is organize as a group. You should consult somebody who's good at this, somebody who's got a legal background, and insist on the addendums that you want. It's so simple, really.
Now, you just said something that was really interesting. You know, as farmers, I'm a farmer down in Ramsey County, and we're really worried about our fences and our tile especially. You're right on.
Right.
Except why did you separate the surface agreement from the lease? Because what we found out later is if we say non-surface disturbance, we also can negotiate what's called a surface use agreement. Like in Texas, they got $50,000 just to a well pad on their property, and then it was $10,000 per well that was put on there.
We had similar language, not quite that amount of money, but we had similar language in our lease.
Oh well, okay.
So and that's exactly what you should.
Well, and no entry leases, which refer to no surface entry, are not that rare in New York. They're certainly done. Usually there's some kind of a trade-off. If you demand no entry, you're probably not going to get as much bonus money as if you don't. But
you can make it up in your surface use agreement.
But sure.
You can also add additional setbacks to mention that.
Oh sure, no, you can add setbacks. You can add setbacks for your buildings, setbacks for your ponds. Certain areas that are off limits, if you will. Let me go on. I mean, you can argue lease language forever. Let me go on.
Thanks, Brayden. My name is Michelle. I'm from Hector Clean Waters. Next month, we're going to opt for another informational meeting at the Hector Firehouse, Thursday, April 25th. And our guest speakers will be Ellen Harrison and Joe Heath. Ellen's from Newfield, and Joe Heath is from Syracuse area, and it's on landowners' rights and leases. So I would welcome any of you to come to the Hector Firehouse, Hector Water. Water, Hector Clean Waters. You can Google us, and you'll find information on that. Again, Alan Harrison and Joe Hughes will be your speakers next month, April 25th at the Hector Firehouse.
Okay.
That man's had his hand up for a long time over there.
Yeah, Braden, I just want to say as a landowner who's been drilled on.
Yeah, incidentally, the only well drilled down at Covert for natural gas was drilled on Kurt's farm.
The gas companies are their worst enemies. They're their own worst enemies. And you really gotta, like the group is saying here, I don't think you can just ramrod these people into saying you gotta drill. You said it yourself, surface water. I mean, when the company, they sub this and they sub that, they send a dozer out, I mean, tile lines, you name it, that's not addressed. I mean, I had a lawyer review my lease, and I think I've heard horror stories from Pennsylvania. You mentioned the Shale thing, you know, that they're going to have future production. They held checks, they canceled checks to some farmers, $500,000, where retired farmers were hoping to get the money. You know, Shell is just kind of waiting for the price to go up, and then they decide to pay them, and the thing is in litigation. You know, that's
well, we had a similar situation in New York too, where leases were taken and then the money didn't follow through.
And I guess we need some real special lawyer. I mean, I'm not totally against getting energy on the ground.
The industry is not blameless in all of this. They've created a lot of their own problems, particually through lease map. I have a number of issues.
In 5 years, these wells, who knows what's left in them? You know, when they come in, they can change the topography even of the ground. I mean, unless they really hold their feet to the fire, that's a problem.
I think, and I'll put in a pitch here for DEC in New York, I think they are much more capable of dealing with the industry than Pennsylvania has been to date. Now, there's been a lot of criticism, a lot of negative comments about DEC. I've dealt with them for 30 years. I want to tell you, you mess with them, they'll mess with you. And the fines get pretty stiff pretty fast. So, and now we've had 4 years of sensitivity accusations, whatever you want to call it. The Mineral Resources Group, as well as the Environmental Protection Waters Group, are fully capable of managing any oil and gas drilling in this state. Incidentally, City of Buffalo water, you can't spill it on the ground legally because it doesn't meet DEC discharge requirements right now.
What constituent? What chemical?
I don't know, but I was told that it does not meet DEC regs right now. It tastes a little nasty. Let me move on to some other comments.
Yes, I'd like to hear what that man over there has to say that had his arm up for like 10 minutes.
He spoke once, so I was just kind of moving my... I'll get back to him. I'll come back. Let me go to this guy next.
Why do you suppose every major city in New York State, including the 2 major watersheds, have banned fracking?
The 2 major watersheds, you're talking about Syracuse and New York City?
Yes.
Both of those watersheds have an exception to filtration. They do not have to filter water. Any other public treatment system in New York State has to filter the water. They can produce raw water to the city without filtration. There's a lot of expense involved there.
And how about
it's sediment.
How about all the major cities in New York State have banned fracking?
Even Ithaca.
Well, that's their privilege. The reality is you can't drill in the city anyway because you can't generate a big enough unit.
But the city has boundaries beyond the nucleus of the town, or land all over the place.
I would disagree with that. But
take the town of Covert. Most of this is rural area, farmlands.
Well, wait a minute, that's not a city. The town of Covert is made up of one village, which occupies quite a small fraction of the town. The rest of it is rural land with the exception of the federal grazing unit, the federal national forest.
But they must know something to keep fracking out of their areas. What do they know that you're not telling us?
I don't have a clue. I'm telling you, fracking will work, and we can manage the problems. No, we are welcome to disagree. That's the beauty of living in a free society. Let me go to this guy.
All right. Thank you very much. And I'd like to thank every farmer in the room for who they are and producing food. Bravo for the farmers. Their land, they're stewards of the land. And I think that's a really important ethic to maintain through all of this discussion here tonight, is that we are borrowing the land for our children in the future. And what we do to it today will impact them. My question to you, sir, based on that ethic, is why in God's name we are using 19th century techniques, drills into the ground to find a source in the geology of the earth, and draw it out and blow it all over the atmosphere and melt the polar ice caps and make a mess of the surface, our air, cancer epidemics, and the like. Why in God's name can't we generate methane gas, which is what you're after here, on the surface? Why can't farmers crop residue? Why can't, forests? I know we do, but I'm talking about industrial strength methane production. Now, why can't we do that? Norway does it, Germany does it, Denmark does it.
Well, they all drill. Huh? They all drill.
They own our leases.
Yeah, but I mean, there's this new industry of,
I want to disagree with some of your basic assumptions. One thing about 19th century technology, I would like to dispute that.
Drilling into the ground to get energy. Why don't we produce it at the surface? We can do that. Farmers can help us do that.
Can you make enough? No, until you either reduce the demand for BTUs, for energy, or you convert to some other form of energy, solar, wind, nuclear, you name it, you're going to need methane, because that is one of the major fuels, coal being the other one, oil, and lesser extent hydropower and so on. They're part of the present infrastructure. And they can be changed, but you're not going to change them in 5 years. You need...
Why? Why can't we generate methane
I think
tomorrow? I mean, why?
You can, but you can't build them fast enough. You can't convert the infrastructure fast enough to make a...
You guys built the infrastructure. The infrastructure is with natural gas. All you're doing is drilling into the ground to find it. I'm proposing building a methane farm, just an experimental one to see if it'll work, on the surface of the planet.
Well, there's research. No, wait a minute. There's research in that direction. But if you listen to our Cornell professor, he's saying we shouldn't be using methane at all. We should be exploiting other issues. No, there's lots of ways to look at this. The reality...
I want to answer why industry hasn't gone surface with methane.
Probably because it's cheaper to drill. It's probably cheaper to develop it this way. Free enterprise system, you generate your energy by the cheapest method.
Water, think of the butane that comes off of separating the gas, the wet gas with the benzines and xylenes and all this.
There's only benzenes in the oil. It's not natural gas. But it's a scope of magnitude, I believe. No, yeah. Let me go over here.
Thanks for the question.
Yeah.
Thanks for the answer.
The first thing I'd like to say to everyone is that there have been many reported contaminated water wells by the exploration of natural gas. And I have a list here, and I will just list a few. But the McMicken family, the Phillips, and the Spencers versus Chesapeake. $1.6 million was awarded to each family by Chesapeake for contaminating their water wells. The Hellowich versus Range Resources, also an undisclosed dollar amount for contaminating their water wells. The Simmons family in Pennsylvania as well. The Manning family, undisclosed dollar amounts for contaminated water wells. These are serious water well contaminations. 15 families versus Cabot Oil in Dimmock in November of '09. Again, undisclosed dollar amounts. Gag orders insisted by the gas company that none of the family members speak of anything, not just the dollar amounts that were awarded, but the actual contamination circumstances. That's one of the reasons we don't hear a lot about it. Again, 2 methane plumes in Bradford County contaminated over a dozen wells and the Towanda Creek. DEP fined Chesapeake $1 million for contaminating water wells of 16 families. Another whole incident. The Maryland DEP sued Chesapeake for water pollution stemming from Pennsylvania's Susquehanna River. West Virginia sued Chesapeake for water pollution and a fine of $600,000, also stemming from a creek in Pennsylvania. Residents living near gas wells, and this was reported by the Environmental News Service, stating over 1,000 families in the last 6 months of 2012 complained about severe headaches, tainted water, polluted water wells, livestock deaths, and fish kills. The first 6 months of 2012, Chesapeake received 30 violations from the DEP. A total violations number in 2008, they have received 284 violations. And also, one more. Consol Energy. Consol Energy paid $5.5 million in fines for a $65,000 65,000 fish that were killed, again, stemming from water pollution in Pennsylvania that traveled down to West Virginia. And there were 2 industries that did separate investigations to find how those 65,000 fish died. The other question, this is just information that I want everybody to know.
Where did you get it? Where did this come from? Where did you get it?
This was all on in newspapers. If you want, I can print it all out for you.
I can clarify the one thing, okay, guys? The one thing she did state was incorrect. It was the $1.6 million for the Phillips, for the McMickens, and the Spencers. That is on Terry Township, Paradise Road. Okay, that is from a gas migration investigation report. You could pull that off the DEP. You have to go to the regional office, which is in Williamsport. All of you are more than welcome to do it. You have to do a file review. It takes 3 weeks to go through. All you ask for is a GMI report, and you will find this. What happened was, those 3 families were awarded $1.6 million. These homes are worth $400,000. When their water was contaminated, the appraisal in Bradford County, and you can go to the courthouse to find this, is $39,000 to $30,000 per home. So what you have to understand is, in the award, it was $1.6 million. 2 attorneys were involved, one from Texas, one from near Scranton area. They took 40% each. Then, they ended up, Chesapeake took the homes. And by the way, if anybody is interested in receiving the royalties from there, you are more than welcome to buy those homes because they're up for sale right now. The deal is, they walked away from the $400,000 homes with only $200,000 in their pocket with health issues, major health issues that this $200,000 will not cover. So, I'm just telling you.
Why would they do that?
Pardon me?
Why would they do that?
Do what?
Why would anybody with any brains walk away from $400,000 house with $200,000?
Because it's appraisal.
She can't live there anymore. The reason why I would do it, because my water is contaminated as well. I brought my water and I brought pictures for you if you're interested.
Well, if it was true, I would get into litigation with them. I wouldn't sell $200,000.
Well, the thing is, you're at the mercy of your attorney as well. And see, the attorney, no, I'm telling you.
You have an attorney, he's just going to charge
Okay,
you.
no, we appreciate the information. If you want to know more, you need to research them.
That's the bottom line. You gotta research.
There's lots of contamination caused by things other than the oil industry. And I'm not telling you the oil industry is a bunch of white knights.
You've never heard water contamination from this system.
Yeah, and
so
you just
tonight,
said
right?
Yeah, right.
It's the first time you're hearing.
First time you heard about it?
No, I've seen water contamination in New York decades
That
past.
lady's telling you.
The claim was there's never been a well contaminated.
Well, but we don't know if, you don't know if this is surface or from drilling.
Yes.
Okay.
You want, the definitions here are the item.
Right.
There's
The
no
dead fish
question.
has got to be surface.
Yeah, you're telling us these have, and I'm not disputing that. I don't know any of the details, so I'm not going to comment. We've contaminated wells with manure lagoons. We've contaminated wells lots of ways unrelated to. No, and I don't want to belittle or degrade the seriousness.
You can't compare because the chemicals that are in the frac fluid are so poisonous, and those poisons do not break down. They are in there, in the ground, and they are migrating into streams and rivers and lakes, and those chemicals will not be able to be cleaned up for thousands of years. Thousands!
You and I are going to disagree on that. We're going to have, for the purpose of this meeting, you and I are going to have to agree to disagree.
The other thing I'd like to bring up is I would like to know why the governor of Pennsylvania has banned fracking from Berks County, Montgomery County, Bucks County, Chester County, and Lehigh County.
I don't even know where most of those are. I know where one of that deals with limestone terrain, correct?
Pardon me?
They deal with different geology. Limestone terrain.
No, just to let you know, a reported 360 billion cubic feet of natural gas is under those 5 counties. But let me just tell you who lives in those 5 counties, may I? Okay. The head of the DEC, the governor of the state of Pennsylvania, the lieutenant governor of the state of Pennsylvania, many state assembly people, several congressmen, and the executive director of the Pennsylvania State Association of the Town Supervisors.
Do you realize it's in the Chesapeake watershed?
The
head of the DEC lives in those 5 counties. There are also many CEOs and vice presidents of all of the pharmaceutical companies that are located in Pennsylvania, plus, may I add, the presidents and the vice presidents of the 3 largest banks in the state of Pennsylvania, and there are even a couple of movie stars that live in those 5 counties.
So it's
now, my
politics.
question to you is, why is there a ban on those 5 counties and nowhere else in Pennsylvania?
I won't speak to the why because I don't know. I'm sure we can say the same about New York. Most of our New York politicians and legislators live in the Hudson Valley and the Delaware River Basin, which is off limits. or will be off limits. So I'm not going to speak to the why, I have no clue. We'll leave
I'll
that
tell
to
you
your
why
imagination.
those counties don't
But
have fracking.
I need to go on to a few other people. I think you made your point.
Because the rich and famous don't want anything to do with fracking. The rich and powerful don't want any fracking in their backyard.
And if I'm rich and famous here with lots of money and no mortgage and secure kids, why would I lease?
Because your water is for sale.
You don't have to, though.
No, my water's not for sale.
Yeah, your water is for sale. You've sold your water to the gas company.
No, I disagree. And even if it's polluted, and as I pointed out, you and I have to disagree because I'm the fix-it guy. I believe we can repair most, maybe not all. You know, you never can prove a negative that something won't happen. So I believe you have to take the opposite tact and say it will happen. And therefore, if you're going to allow fracking to go forward in New York, we've already fracked 40,000 wells in this state over the years, not with the same volumes that occur in horizontal wells, for sure.
I can tell you that state ban discriminates against rural communities, protecting the health and welfare of the rich and powerful counties.
Okay, that's your opinion. I have no problem. This guy has his hand up. I'm sure he wants to shot at me.
Evening, folks. Craig Stevens, Silver Lake Township, Pennsylvania, 6th generation landowner. My mom's from Oswego, right up the lake there. I'm 5th generation New Yorker. I'm a common target of Tom's group EID because I speak up. They think I'm a left-wing anti-drilling activist, but they didn't have a booth at CPAC 2 weeks ago called the Tea Party Nation, like I did. And they're trying to talk the conservatives quit for them going down the wellbore hole with the industry, because if you don't know it, you covered it earlier, they're going to come here and poke holes and cap them and split until they're ready to come back and take this gas. Don't let them anywhere near your property. I got introduced to my grandmother being signed by Chesapeake in a nursing home at 95 and a half years old. She didn't own one blade of grass. Her children that she gifted it to 14 years earlier owned it. One of them, which was my dad, who had died, and I then was owning the property when they signed her and recorded that. That's who you're dealing with. These people have no morals. They don't care. He knows that. They come in, the landmen come in, and they are snake oil salesmen. That's their gig. Here's the issue. You covered it. They're going to come here. They're going to drill holes and cap. Now they hold everything, including if you're forced pool, compulsory integration. Sounds a lot nicer. When you're forced pool or compulsory integrated, you get drawn in whether you sign anything or not. That's ridiculous. I've got the Constitution. I'm a constitutional conservative, not a right-wing person. There's nothing in the Constitution that covers what they're doing in Pennsylvania to all of us and what they're planning on doing to you guys. There's Demick. Anybody that wants to after this meeting come up, I will show you what happened in Demick. I've got the legal documents right here. I don't open my mouth because of EID without my documents to prove what I say, because they're calling me all kinds of names, liar, convict, everything else. That's what they do, attack your credibility personally. There's PASA. Do you know who that is? PASA? No. Pennsylvania Association for Sustainable Agriculture. 6,000 farming members in the state of Pennsylvania. They hosted Farm Aid this year. They were the main sponsor. Let me read you very quickly their paragraph. PASA asserts its position in favor of a moratorium on unconventional gas extraction till it is determined that this practice will not impair the ability of farms to profitably produce healthy food while respecting Pennsylvania's air quality, water resources, and the natural environment. That is the largest sustainable agriculture group of farmers in the state of Pennsylvania. That's what they think about the industry. Now, to this thing about the water. Guess what? My water's still fine. The closest well is Shale to Pew, a mile from me. Of course, Shale put out Truthland. Go ahead and watch it. It's a 35-minute laugh riot. Here's why. I have the documents here to prove 4 out of Shale's 10 gas wells had well casing failures. She says in the movie, they blow one up and say there's no evidence of well casing failure. Hey, Shelley, who lives a mile from me, my neighbor, why are you lying in your movie Truthland about no well casing failures when your own property had 4 out of 10?
I know the Pew really well.
Me too. They've been our neighbors since
I never
4
heard anything
generations.
about any bad wells, and I know Phil.
I've got the documents right here. Got the documents. Lastly, I've got them right here showing the DEP documents. Lastly, pick up a copy of the National Geographic this month. Look at the cover. That's North Dakota. They are burning all the gas there. That's how much methane is worth in North Dakota. It's in the way of the oil. That's what they really want, is the oil down below the shale. They are burning it. You know why? Keep them out of here. Keep them out of here until the gas, if you want money, don't do it at $3 a thousand. That's ridiculous. It was $16 a thousand just a few years ago in Pennsylvania. And now they're getting creative because Chesapeake's broke. You ever heard of a mechanics lien before? Look up Bradford County. Millions of dollars of mechanic liens because Chesapeake is 6 to 8 months behind or more in paying their contractors. And what do? Because you're an idiot that signed a lease with the company, you're a partner. And guess what they do? Put a $250,000 mechanics lien on your property. Are you kidding me? These guys are here for money to make money on our backs. That's what they're doing. And guess what? Tell me, Tom, they tell you how much is coming out and what they're paying on. I'll end it with this. I just went to a meeting about 3 weeks ago, and lawyers were there. They're going after Chesapeake because for 4 years, these big farmers with 500-acre properties near us have been receiving some pretty damn good royalty checks until recently when the price dropped. But guess what? Their production costs they were being charged went from 4 to 5% on their checks to 40 to 50% production costs. Now, here's the interesting part. Their partner, Statoil, by the way, which owns 1/3 of the mineral rights under my property, America's Fuel. Statoil is owned by the country of Norway. They own 1/3 of every lease, 32,000 leases in the Northeast. America's Fuel, Here's the funny part. Statoil is still only charging 4 to 5% on the checks that they pay to those same owners. And Chesapeake upped it to 40 or 50%. They told all of you and all of us, the reason we're getting paid the short end of the stick, 12.5 or 15%, is we're just getting easy money. We don't have any investment. We don't put any of the money into it. Why then are they coming back and charging all of us landowners massive amounts of money? We're paying for that well. They didn't pay for that well. We're paying the millions of dollars for it going in. I'm tired of getting lied to by these guys. And Tom and EID and all these people are paid promoters. I'm not paid to promote anything except for my property, which has been in my family for 181 years and will be passed to my 4 children, will not be destroyed by this industry to make money. Because you know what, Tom? I want to know what EID's position is on how much are they supposed to pay me so I can turn my backs on my own neighbors when their water goes bad. Because I won't do it. I bought a water truck and am delivering water to the people in Dimick that Tom says aren't contaminated still. You know why? Because that's what neighbors do and that's what a community is. And I don't care how many people around $1,000 bills. They're not your friends. They're not the people.
Yeah, no, I will just say,
very good.
I will just say in comment, I disagree with a number of the things he said, parts of his statement.
I'd like to ask you one more question, sir, and then I'm not going to bother you again. One question. Once they find gas or oil on your property, and we're talking about gas from the Marcellus, can a landowner who signed a lease say, get the hell off my property? If they have a spill, if they have nothing, can they say, leave now?
No.
I want you all to know that.
No.
Okay?
No,
In
it's a
50
contractual.
years, when your children need a place to live, you won't have it. Is that worth $1 million to end up with $5 million in the hole so Norway can keep warm? What the hell's wrong with you? Don't sign the lease.
Settle down.
Let me go to this
Can't
guy
talk
over
here and close the door.
Right here.
I do actually have a question.
Okay.
I was having trouble coming up with some worldwide statistics. You know, we're looking at, a gas boom all over the globe. When Bill Capel came a couple weeks ago, I pulled up the USGS website, and it states there that we have geologists are addressing problems with past industrial pollution of water, that our lives depend on the water. And he had some statistics about how many gallons of pure chemicals were in each frac, but it was hard to get statistics on. We're looking at millions and millions of wells that the companies would like to drill. So it seems like the plan is to have trillions of gallons of water mixed with billions of gallons of chemicals, and then the disposal options listed in Bill Capel's article mostly involve some sort of surface disposal, which essentially puts this combination of water and chemicals back into the environment. It seems like you're suggesting that pumping it down into the ground is a stable option in your opinion, but that's not an option for most of this water, is it?
Well, the option for most of it is reuse. I think your numbers are kind of big. There's a little over 40,000 wells a year drilled in the U.S. I think worldwide it's something comparable. I can't speak to China, I don't know. What the more U.S. wells are fracked than wells worldwide, again, I can't quote statistics. The rules in New York, or the goal, probably goals are better than rules, in New York have been recycle, reuse. We recycle, we have bi-weekly recycling of household waste around here. No reason not to apply that to the energy industry.
But you
Recycle.
can't use this water, isn't that correct? You can't.
No, you can treat it. And in fact, the technology is changing so rapidly, we can treat most of it right on site if we choose to.
Take that radioactivity right the hell out, though. Just take
Yes,
it right out.
Where do
you put it?
the technology, no, you've got, the radiation material doesn't go away. So you've got to do something with it. And the best place for it is put it back where it was. Now, the radioactive portion, if you separate it, is quite small. Less than 1% by volume.
But there's also bio. Once they find gas or oil on your property, and we're talking about gas from the Marcellus, can a landowner who signed a lease say, get the hell off my property? If they have a spill, if they have nothing. Can they say, leave now?
No.
No. I want you all to know that.
No.
Okay?
No,
In
it's a
50 years,
contractual.
when your children need a place to live, you won't have it. Is that worth $1 million to end up with $5 million in the hole so Norway can keep warm?
No.
What the hell's wrong with you?
Hey,
Don't sign
hey,
the lease.
hey, settle down.
Let me go to this
Can't
guy
talk
over
here and close the doors.
Right here.
I do actually have a question.
Okay.
I was having trouble coming up with some worldwide statistics. We're looking at, a gas boom all over the globe. When Bill Capel came a couple weeks ago, I pulled up the USGS website, and it states there that we have geologists are addressing problems with past industrial pollution of water, that our lives depend on the water, and he had some statistics about how many gallons of pure chemicals were in each frac, but it was hard to get statistics on. We're looking at millions and millions of wells that the companies would like to drill. So it seems like the plan is to have trillions of gallons of water mixed with billions of gallons of chemicals. And then the disposal options listed in Bill Capel's article mostly involve some sort of surface disposal, which essentially puts this combination of water and chemicals back into the environment. It seems like you're suggesting that pumping it down into the ground is a stable option in your opinion, but that's not an option for most of this water, is it?
Well, the option for most of it is reuse. I think your numbers are kind of big. There's a little over 40,000 wells a year drilled in the U.S. I think worldwide it's something comparable. I can't speak to China, I don't know. What the more U.S. wells are fracked than wells worldwide, again, I can't quote statistics. No, the rules in New York, or the goal, probably goals are better than rules, in New York have been recycled, reused. We recycle, we have bi-weekly recycling of household waste around here. No reason not to apply that to the energy industry.
But you can't reuse this water, isn't that correct? You can't.
No, you can treat it. And in fact, the technology is changing so rapidly, we can treat most of it right on site if we choose to.
Take that radioactivity right the hell out, don't you? Just take
Yeah,
it right out.
Where
do you put it?
The technology, no, the radiation material doesn't go away. So you've got to do something with it. And the best place for it is put it back where it was. Now, the radioactive portion, if you separate it, is quite small. Less than 1% by volume.
But there's also biocides and...
We have another question.
If you look in the current industry literature, there are companies bragging that they have 100% biodegradable frac fluids. Now, are they, I don't want to drink them, but...
well, if you don't want to drink them, then you don't want to put them back in the rivers and the streams.
Correct, correct. Surface disposal is not enough. In fact, in New York, surface disposal liquid right now is illegal. You can't even get rid of a tanker load of milk legally on the surface. The only way you can do discharges legally is a speedies permit.
So, but last summer we had a drought here. Was it last summer?
Yeah, last summer pretty dry.
So water, people were running out of water in their wells.
Somewhere, yeah.
Yeah, so if you're pulling tens of thousands, hundreds of thousands of gallons of water, and that won't be going back into the aquifer or groundwater, are we making a borderline situation seriously?
I think the order of magnitudes are quite different. And the industry can give you numbers on the volumes of water that are used. And you know, water, there's a drought or a flood every year. As long as I've been around, some places they got too much and too little. Somewhere.
Well, they are increasing because unlike the story you had in 1903, those people weren't facing the kind of environmental pollution. They were afraid of new technologies that are silly, but what we're afraid of is climate change, and 81% of the lakes and rivers and streams in our country are, the EPA says this week, are not healthy. 81%. So we're talking about the ultimately most valuable resource.
So what we need to say is no surface disposal.
But what about, but you're taking all that water out of potable, out of use. You're not all that water.
But we can frack with non-potable water. We haven't, because the potable water, and in fact, the Susquehanna River Basin requires you to purchase water either from a municipality or an approved water source. And you can apply for a new water source. It takes a couple of years to get one. It's been the biggest problem. Most of the industry has been purchasing municipal water for use in the Susquehanna River Basin. I can't quote the percentage, maybe Tom can, but there are water sources that are permitted in existence. I know where there's one on the New York side of the line, the Susquehanna River. It's been there for a number of years. That person can pump, I can't tell you what his daily allowable is, but he's allowed to pump so much. When we were working at Avoca 20 years ago, we had to monitor the river prior to water withdrawal, so they had a percentage of the river flow that could be withdrawn. This was permitting from the Susquehanna River Basin Commission. So, I mean, and quite frankly, you can frack with anything that's liquid, as long as it's clear. It can't be cloudy because we don't want to plug things up. We gotta remove the particulate, anything that's not soluble. Which we can frack with the sewer discharge, quite frankly, right out of the sewer plant. graywater reusage. We can frack with seawater. I mean, if there's a legitimate shortage of fresh water, we would hope the regulatory agency says you can't have any more, or you can only have so much. And then, well, case in point, in the West, you have water rights. In the East, water law is rule of capture. Now, that's been modified. The state of New York, if you have the ability to pump over 100,000 gallons a day, you then have to register with the state of New York. If you're not a farmer, you pay a fee. And I'm sure there will be situations where somebody will be deemed to using too much, and the DEC will attempt to limit that. That's a work in progress.
Combustion yields water.
Oh yeah, no. And you're right. You know, global warming deals with putting it in the atmosphere. He forgot to mention when he showed me the picture on of the cover of the National Geographic, the EPA has proposed banning flaring of gas after 2015. That's proposed, not law. The state of New York, I can't flow a well for longer than 24 hours if I test it without a flare permit.
Pennsylvania, you can do whatever you want.
Right. Pennsylvania flares. And quite frankly, I've criticized the industry for the flaring. What's the point? It's done. I know why it's done. It's done for engineering analysis, but we don't allow flaring like that routinely in New York under present law. Now, I can flare, and if I have a situation where a well's gotten away from me or something of that nature, it's preferable to burn it so you know where it is than have it running around waiting to blow up on you. No, New York has a reputation for pretty stringent environmental laws, and we don't expect them to slack up any in terms of dealing with the oil and gas industry.
My question is, how did Halliburton, or why did Halliburton manage to remove hydraulic fracturing from the provisions of the Clean Water Act?
Actually, I don't think it's entirely removed. There are certain elements that are removed. Part of the Clean Water Act deals with the definition of fresh water. If water has greater than 10,000 parts per million,
contaminants.
Contaminants is the wrong word. It's total dissolved solid, is the correct term. It's not considered potable water. In fact, New York State's requirements are quite a bit more than that. So that was legislated. You can argue that it was a loophole or favoritism or whatever. We can debate that forever. No, I have no way to. I wasn't there. I have no way to speak to that other than the Clean Water Act. The contractor on the blowout in the Gulf of Mexico just paid a $1 billion fine for violations of the Clean Water Act. So it wasn't entirely exempt. And I don't know whether that referred to what happened in the Gulf or what happened on shore. I don't know. Same problem as we're hearing here. We don't know the details.
Federal oversight is what they did. They don't allow we call the EPA, and they say it's about oil and gas drilling. They say you go to your state. But our state has turned their back on us a long time ago.
Then you need to go to Harrisburg and speak to the folks there.
They won't even let you in. They won't even let you near them. That's the problem. They're
well, I don't know what I can say about that other than vote. But no, in my point is there is risk. There will always be risk. There's risk in growing corn, soybeans, you name it. We're going to do our very best to manage and minimize the risks in the oil and gas industry.
Yeah, right. I think they're going to leave it at that.
If you're comfortable with that, fine. If not, yes.
13 years ago, I had my business, made a lot of money. I had a good account. Told me I need to invest some of my money so I wouldn't have to pay taxes. So I invested in 3 big wells. A lot of money, $250,000. First year, I was getting on each one of them wells $1,300 to $1,500 a month. Good money. For a while, a year and a half went by, started going down. From Atlas, you've heard of Atlas?
Yeah, yeah, they're a company.
Right, yeah, big company,
Yeah.
big company, right?
Yeah.
But I can take everybody here right now. I'm getting $53 on one a month, 62 on another, and 48 on the other. I'll probably be 150 before I get my total investment back.
If ever.
If ever.
If ever.
But that's just what the companies do to people.
I want to, yeah.
I mean, and that is fact. It's in black and white. I get a monthly statement, and
I want to challenge one of the things you said. You said you had a good accountant. I disagree.
Well,
I think you got very poor financially.
you know what?
But the oil industry.
But you know what the one good thing was? See, I had a trucking company. I worked for W.R. Grace, and I got to write it all off. So I don't look at it as a bad investment, you know, because
Because you got in New York State, it'd be 42 cents on the dollar.
Right, so you know, so I got to write off everything. You know, so I did good anyway. But you know what? It's just to tell the people that what you get is only going to be just a little bit for a while. It will run out.
Oh yeah, no, and in fact, if you know of people in the particularly Chemung County, there's a number of school districts that were living pretty high off the royalties from the Black River. Excuse me. In New York, let me back up. In New York, it's been said we don't have a severance tax. What we have is a property tax instead. The state of New York, as soon as you develop production, 3% of that production is assessed back to the well owner based on their production. But it does not go to the state. It goes to the town and county.
My wells were in
tax base.
Pennsylvania.
You're a different arrangement.
But my wells were in Pennsylvania.
Yeah, but I'm saying in New York we have a different arrangement. But
oh, and it would probably be the same too. It wouldn't be much different.
well,
actually with the gas,
I think you'll find it is. The federal laws are obviously the same, but not the state.
well, it all depends how much they say they're pulling out and making.
Yeah. Oh yeah. Yeah. No. Based on production. Severance taxes are based on production.
In your presentation, you mentioned several points in the process where things can go wrong.
Sure.
And you've actually witnessed some of these things going wrong. And I just want to point out that if we bring this into our community, that will happen, and there will be wells contaminated, and there will be streams contaminated. It's just it's a matter of probability, and it's going to happen sooner or later over thousands of wells. You also mentioned that there were some tailings that were measured by the state, and they were not radioactive.
Stuff.
Yeah, but then I would say there are other ones that are radioactive. So I mean, the fact that you can point out the fact that you can point out something where it went well, where things went well, there are also things that go wrong. You know, and Mr. Shepstone said he can show you some roads in Pennsylvania where the road was in good condition. Well, somebody else can show you roads in Pennsylvania that are in bad condition. So I'm not concerned about the times when things go well. I'm worried about when things don't go well, and that is going to happen in this community. And what we have to decide is, as a community, do we want to bring that in? Do we want to create winners in the community? Some of these guys are going to make a lot of money. Other people are going to. Pardon me?
Is that what you're pointing at me?
No, he's pointing at me.
Well, I think you probably will. If things go well, you probably will. Anyway.
Things went well, you probably will.
Well, my land is not.
I didn't say that. I said if things went well, you probably would.
Yeah, well, not through gas. No,
you wouldn't?
No. Anyway, but there will be winners and there will be losers. Some people will lose big. It's possible your wealth will get contaminated. A lot of people will get a little bit of money. Maybe they'll get a job driving a truck. A lot of people will get inconvenienced with the truck. So my point is that they're going to be good things. They're going to be bad things. A lot of people don't want. We don't want to have that kind of community where there's winners and losers, big winners, big losers.
You got that now,
water
though,
contamination.
Isn't that what we have now? Winners and losers. Maybe not in regard to oil and water wells.
Now you have to work for your money. Right? You have to work for your money.
Yeah.
Getting somebody to come in and drill gas is not working.
The problem, you can't freeze the present society. Look at the evolution. Look, I mean, I'm old enough to have worked before cell phones. I didn't even grow up in a house that had a TV. Look at the evolution of things that have occurred in one lifetime, good and bad. And as I said, while you can never prove that a negative, that something won't happen, we want to maintain our best efforts to minimize them.
Yeah. But my point is that in spite of your best efforts, there will be problems. You've witnessed them yourself.
In the past. And hopefully,
you will witness them again in the future.
And hopefully we can learn from the past, to minimize.
Hopefully.
Beg your pardon?
If they're not going to drill here, why do we have to learn anything? See, you say we're not going to drill, but then we're saying they're going to drill.
No. Eventually we will drill in New York. The reason why drilling won't New York State. And I'm saying, based on my analysis, it will be this area for economic and geologic reasons.
I'm out of battery. I didn't realize they ran out so quick.
You said that.
I gotta get a bigger battery, I guess.